Good morning, everyone. Welcome to SPM Chemistry webinar organized by SMK Methodist Sibu. First of all, allow me to introduce myself. My name is Rafe Hee Jin Hao from SMK Methodist Sibu. I will be the moderator of the webinar today, and I would also like to extend our warmest welcome to the speaker of today, Mr. Peter Chin Sing Kiong, who will be sharing with us some useful tips to strive for excellence in Chemistry SPM 2021. Now, I'd like to invite Peter Tang to lead us in an opening prayer to kickstart our workshop this morning.
Let us pray together according to our own belief. Dear Lord, we put this webinar today in your hand. May you lead throughout this whole webinar and let this webinar can go on very smoothly. Bless our speaker today, Mr. Peter Chin, so that he can teach every student about the knowledge and the answering technique of chemistry. Also give our students good understanding about what is being taught today, so that we can benefit from this webinar and we can apply everything that we learned today on the exam and on the SPM. Bless every one of us who is attending this webinar, and in Jesus' name I pray, Amen.
Thank you very much, Peter. Now, I would like to invite Mr. Adli bin Chikba, the Education Officer from PPD Sibu, to say a few words. Ladies and gentlemen, sorry for some technical issues that have occurred. Now, we would like to invite Mr. Philip Ling, the principal of SMK Methodist Sibu, to say a few words.
Thank you, MC. Good morning, Mr. Ali Chikba, the head of Sibu Education Officer. Our speaker, Mr. Peter Ching. Ladies and gentlemen, hopefully all of you are doing well today. On behalf of SMK Methodist, it is a great pleasure for me to welcome all of you. Thank you for making the time to join our webinar today. I believe today is going to be a special and memorable day for all of us because we have participants not only from different schools in Sibu, but also from other districts as well. Now I guess we are reaching nearly 500 participants or more. First and foremost, we are really thankful to Mr. Peter Ching, who is willing to take the time out of his busy schedule to be with us today, sharing his knowledge. For your information, SMK Methodist has been organizing different workshops for different subjects consistently for students to gain more information to excel in SPM examinations. What makes today more special than any other days is that this is our first launching of our very own YouTube channel. This remarkable moment right now marks our first YouTube channel to kick off all the programs for SPM students after this. Ladies and gentlemen, the motto of this channel is Strive for Excellence, which aims to assist students to perform excellently in SPM. This channel is run by our own students, facilitated by teachers. Well done to the committee members of YouTube channel Methodist for your excellent initiative and hard work. May this channel in future be a platform to serve and provide more highly engaging, fruitful, and beneficial information to everyone. I would like to express my heartfelt thanks, especially to Madam Francisca Lau, the head of chemistry department, and the committee members who sincerely committed to this event to make it a success. I would like to also grab this opportunity to welcome all teachers and students from other schools. May all of us gain more benefits through sharing from this morning webinar. And this event would have been impossible without the support of each and everyone present here. I'm sure that we all will feel enriched with knowledge by the end of this webinar. We are extremely hopeful that this webinar is also going to be a great success like every other year. I welcome you all once again to the webinar and hope that you all will have a great time ahead. Thank you and God bless you all.
Thank you, Mr. Philip Ling. Now, I'd like to introduce the speaker of today, Mr. Peter Chin Sing Kiong. Mr. Peter is a very experienced chemistry teacher with 12 years of teaching experience. He is currently teaching at SMK Desa Kencana, Lahad Datu, Sabah. Moreover, he is also the master trainer for KSSM chemistry for the Lahad Datu district. He graduated with a bachelor degree of chemistry from a prestigious and well-known university, which is the University of Bristol, UK. He has also received a diploma in education, specializing in chemistry from the IPG campus Darul Aman, Kedah. Over the years, he has accomplished various wonderful awards, one of which is the Icon Guru Stamp Lahad Datu 2021. This morning, it is indeed our great honor and pleasure to have invited Mr. Peter to share with us some tips to excel in SPM Chemistry 2021. Our webinar this morning consists of 2 sharing sessions with a 10-minute break in between. While listening to Mr. Peter's sharing, please feel free to type your questions in the chat anytime. Please be reminded that the participants are only allowed to ask questions that are related to chemistry. The last 10 minutes for each session shall be allocated for Mr. Peter Chin to answer all the relevant questions. Without further ado, we shall now invite Mr. Peter Chin to start his sharing session.
Thank you, MC. A very good morning to all of you, and I do hope all of you are in the pink of health. Okay, what I'm going to share today would be related to chemistry, paper 2, paper 3, as well as slightly a bit of paper 1 and a bit of tips of answering as well as memorizing some things. Okay, but what I hope to share with you is that students as well as teachers could benefit from this and definitely will be able to achieve and strive for excellence in their chemistries. Okay, without further ado, okay, I would like to introduce the paper first before we're going deeply into the paper itself. Okay, so for chemistry, For chemistry paper, there are in total 3 papers. Okay, I guess all of you who take chemistry should know that there are in total 3 chemistry papers. Paper 1 consists of 40 marks, okay, which is consists of 40 objective questions. Paper 2 consists of 100 marks, and students have to at least answer 10 questions out of the 11 questions available. And paper 3 consists of 15 marks for each item. These correspond to one item from bio, one item from physics, and one item from chemistry. It depends on the options of the students. Means if the students takes physics and chemistry, or bio from chemistry, then they will have to have only 2 items in the practical examinations. Paper 1 and paper 2 are written examinations, while paper 3 is a practical examinations. Okay, these are all the overviews of the paper. You can actually have a look further into it. But most of the time, your teachers and you actually see these examinations questions in your trial as well as your normal examinations. Okay, paper 1 consists of its allocated time is only 1 hour and 15 minutes for 40 questions. And as for paper 2 is 2 hours 30 minutes, and for paper 3 is around 45 minutes per item. Okay, so let us go deeply into our first slot, which is in this case paper 3. Okay, so for paper 3, it is a combination of 3 items or 2 items depending on the subjects taken. If the students takes only 2 items, then eventually they are only allocated 1 hour and 30 minutes of their time. However, for those that are taking full set or full package of a science stream subject, you will be given 2 hours and 15 minutes, of which first 15 minutes or the first 10 minutes will be allocated to check, basically for the checking process only, to read the instruction and checkings of the materials and apparatus. For the next 2 hours or the next 1 hour and 20 minutes, okay, depending on your options, you will do your experiment as well as answering the questions given in the paper. Okay, the exam day, as we have checked, okay, usually this is what we've been planned. Okay, this is what have been planned is the exam day will be a totally different day compared to the other science stream paper. Means it's not at the same day as the normal bio, physics, and chemistry paper. Okay, so in total there are only 15 marks, okay, per item. So if from bio is 15, chemistry 15, and then physics 15. Okay, the questions can be either a quantitative questions or a qualitative questions. A quantitative questions would usually means that they are not going to have a lot of numbers, or they are not going to have numbers. They are only observations and inferences and variables on that sort. However, for qualitative questions, you will have the options of have to get figures or repetitions of the experiments, or even certain readings of which you have to read the apparatus correctly and neatly. Okay, so there are lists of experiments that you have to do in the SKP. Okay, but one thing for sure, although there are 45, not all of them going to come out. There's only one of it. But as far as I know, paper 3 are not going to come out. Usually the questions that are going to come out might not be exactly, it might be slightly different. Okay, it could be different from the one in the textbook or the SKP. Okay, that is for sure, and that's for certain based on the sample given by the lembaga peperiksaan. Okay, for paper 3, you will be tested at least when I say at least, that means that it can be 7, it can be 8. Okay, at least 7 of the following science process skills: observing, classifying, measuring and using numbers, inferring, predicting, communicating, using space-time relationship, interpreting data, defining operationally, controlling variables, hypothesizing, okay, experimenting. But definitely sometimes the teachers and the students might actually feel, do I have to write down procedures and things like that? This is what I can tell you. For paper 3, there would not be questions about procedures because that is not the skills that you will be asked about. Okay. However, by using or basically controlling variables, sometimes there are questions asking you, how are you supposed to define, how are you supposed to control the variables? How are you supposed to alter the variables, the manipulated variables or the responding variables? How do you get the answers? How do you control the fixed or the constant variables? Those kind of skills. So as far as I know, for paper 3, it will be very easy for you to score. Okay, as we know earlier, they are in total 15 marks. However, I can assure you, even if you accidentally make the wrong judgment or actually make the wrong readings in your experiment, okay, then you still would not be able, you still will only lose, okay, around 3 marks. So that means 12 marks out of 15 is still a possible marks for you, okay. But of course, since we're striving for excellence, most probably you would want to have 15 out of 15. Okay, so this is the skills. The one with the tick is the skills tested in the sample given by the LPM. This is for chemistry only. Okay, I'm not going to discuss about physics and biology. We're going to go straightly into chemistries only. Okay, so the first 15 minutes, okay, 5 minutes per item. Okay, the first 15 minutes is used to read and check the list of materials and apparatus, but it is not, okay, as I told you earlier, it is not to carry out the experiment. The main purpose is actually to check the list, whether or not you have the materials and apparatus on your table or not, and whether the material and the apparatus is completed according to the specification given in that questions paper. Okay, then the next 2 hours, or okay, depending of your subject, if you're taking only 2, it's only 1 hour and 20 minutes. Okay, and for the first 10 minutes. Okay, so they are going to be used to carry out the experiment. So that means if you consider this aspect, the time given to do the experiment as well as to answer is only around 40 minutes allocations time. So that means you are only given around 10 minutes maybe to do the experiment, and to answer the questions is around 30 minutes. Okay, of course you might accidentally drop something or might accidentally cause some because you're panicking because it's the first time you're taking the examination. Okay, you might actually accidentally drop something, and you might actually broke a beaker or test tube. So if that thing happen, if that case happen or that accident occur, please go and ask the pengawas, okay, to ask for your teacher to help you and assist you on that. Your teacher can help you, bringing you a new apparatus, as well as asking the lab assistant to help clean it up after you. So you do not have time to clean up after yourself. Okay, you do not have time to do that. Do the cleaning up after you finish answering the questions. Okay, so you are allowed to answer, okay, whichever questions you want first. Whether you want to answer the chemistry first, or do you want to answer the biology, or do you want to answer your physics paper first? Okay, whichever item you can answer it. Okay, and then please, this is the tips, the most important tips for you in paper 3. Never afraid of glassware, and please learn how to read the levels correctly. Okay, please learn how to handle it, and then please learn how to clean it afterwards and store the apparatus and material correctly. The main reason is so that you do not actually cause any panic during the time of the experiment. Okay, so we're going to look into the questions. Okay, this is the sample given, and we're going to do a bit of discussions on it so that we can see the questions clearly. Okay. Okay, this is the questions being given. Okay, for the questions, usually you will start off with a list of materials. Okay, they will have question 1, 2, and 3, and the list of this checklist. Okay, it will be given on the first page, first, second, third page. The first page, of course, will be in this sample is the physics one. The second is the bio, and the third one, the second one is chemistry, and the third one is the biology. Okay, so as far as we can see here, this is straight away for chemistry. I'm going to take chemistry, and you only have to check whether the materials or the apparatus is available on your table or not. You do not need to check whether the concentration is 2.0 or something like that. You do not need to do that. You only need to know that it is available on your table, whether you have this material or not. If it's available on your paper, basically on your table, then you can always just tick the answer. Okay, just tick. If it's available, just tick it. If not, just make a note somewhere. Okay, just make a note anywhere. Okay, for example, okay, the magnesium ribbon, you can only see on your table is only 2 units, so you can actually make a note there, 2 unit, And then once the you can actually ask your teacher to maybe check for you and maybe open it, because you cannot touch the material first. Okay, so and see whether or not they can help you, and see whether or not actually maybe it is buried down deep down, or it was misplaced somewhere. Okay, and whether the beaker is labeled or not, that is not your duty. Your duty is to carry out the experiment and to check whether or not all of this material is available or not. Okay, so if you actually see, this material consists of beaker containing hydrochloric acid, magnesium ribbon, bottle filled with distilled water, beaker labeled set 1, 2, and 3. Okay, measuring cylinder, two types, 100 centimeter cubic, 25 centimeter cubic, stopwatch, glass rod, and dropper. So all of this material, if you want to test it during the 2 hours, the beginning of the 2 hours, please test your stopwatch first. For me, I would recommend to test your stopwatch whether it contains batteries. Maybe the battery is dying or something. So yeah, test that first. So next, if you actually have extra time after checking for the first 15 minutes, you can read and browse through the questions. Okay, the questions will be given to you only on that day. However, the material and apparatus, all those things will be provided, will be prepared earlier, and you do not know that. Maybe your teacher might know about it, but they have sworn an oath not to give you any tips. Okay, so one of the factors affecting the rate of reaction is the concentration of reactants. Read every details. As I said, for paper 3, it is very important to read every details. And when you read all these details, it is going to give you the tips, okay, on how to answer. And maybe the answer is available here. And pro tips, all the answers in the paper. Okay, all the answers is in the paper. Okay, so let us continue. You are supplied with 2.0 mole of decimeter cubic hydrochloric acid. From the supplied hydrochloric acid, you are required to prepare 3 hydrochloric acid solution with different concentrations. Okay, through dilution method by referring to table 1, using the formula given and the data obtained to calculate the concentrations of the diluted hydrochloric acid. So if you actually check and read it carefully, you will discover that the formula for calculations of dilution is also provided, which actually in paper 3 will be provided for you easily. So what you have to do is make sure you know how to substitute the V1, V2, M2, okay, M1, sorry, all this figure, and place it into the equations, and you'll be able to get your answer. So 2.0 times, okay, 45 divided by 50, and you will get the answer 1.8. Do the calculation, you're getting 1.4 and 1.0. This is the concentrations that you're going to use and you're going to deal with during this particular experiment. Of course, the questions could be different. And just remember, when it comes to calculations, it will not be very hard and you do not need to memorize any formula, because they are going to, whether or not you know how to substitute in the value. And please read and pay attention carefully to all the details, like V1, V2, and M1. You will discover M1, V1, V2. All of it is given. This is M2. Okay, next, when you're reading the steps and the materials, okay, do it step by step. Sometimes it's better to read an overview of it first before you do the experiment, because sometimes when you just straight away do and follow the instruction, you might miss out a few things. An example is the stopwatch, whether it is functioning or not. Because when it comes to the time you have to start your stopwatch, the stopwatch is out of battery, you cannot get your result. So you have to be careful on that. Okay, so step of dilutions. By using measuring cylinder, measure 45 centimeter cubic of hydrochloric acid and pour it into the beaker. Okay, so you're asked to pour into the beaker, okay, 45 centimeter cubic. And since you're having 2 measuring cylinder, you have to be careful and have to use the correct measuring cylinder. Okay, as you can see, 45 centimeter cubic is definitely more than 25. You have the 100 or the 25. So the most logical option is to choose the 100 centimeter cubic measuring cylinder. There's no way you're going to repeat 20 and then 25 to get the 45 centimeter cubic. You're supposed to get the 100 centimeter cubic measuring cylinder. What if you make this mistake? Don't worry, just clean it up and then after that repeat the process. Here, because it is even saying in the step number 2, by using the 25 centimeter cubic measuring cylinder. So here is given the volume. The first one is not given the volume. So measure 5 centimeter cubic of distilled water and pour it into beaker containing the hydrochloric acid. If you see, the step is actually very specific and it's very easy to follow. Stir the solution using glass rod, not using your finger. Glass rod. The solution is prepared, then will be used for part B. So when they said this step, just place it aside. Do not say, what is part B? Straight away go to part B. No, just put it aside first. Whenever you find this kind of step, just put it aside. Just leave it be and make sure you note that this is step 1. Okay, if sometimes your beaker does not have any label, please just make a note this is step 1. Then by using table 1, repeat the dilution steps, okay, to prepare the solution for set 2 and set 3. So as far as I can see, this one is the same thing as above, okay, except you're going to change the volume here, 45 and then 5. You're going to change it according to this table, which is in this case 35, 15, 25, 25. Okay? Next, after you have done this step, it told you to calculate the concentration of hydrochloric acid using the formula given in table 1, which were done earlier. Okay? Which were done earlier. So once you have done the calculation, you can just skip it. And since the answer is correct, okay, so you are confirmed to get 1 point here. Okay? Next one, for part B. Okay, this is the crucial part. As I told you earlier, you have to check whether your stopwatch is functioning or not. Okay, so diagram 1 shows the apparatus set up to determine the rate of reaction between magnesium and hydrochloric acid. One thing I realized, the question even give you a diagram and a picture of it. And sometimes it even give you the answer. Okay, that is the most important part. You have to notice this because they actually give you some answers. Okay, number 1, okay, what you have to do is magnesium is added into hydrochloric acid. Okay, this is the step given. And you can see a gas bubbles as well as a brown solid suddenly disappeared or dissolved into a colorless solution. Okay, when you actually do your experiment, it might not actually come out as it's such. Basically, it is possible it might not come as such. But since the diagram is given and the picture is already given, okay, for you to make a note of it means if you, okay, say for example, you are so panicky and you do not have time to even do the experiment, you can still see the picture and the diagram to help you in answering the following questions. Okay, so this is the experimental steps. Put 3 centimeter of magnesium ribbon into hydrochloric acid in the beaker labeled set 1. Okay, and then start the stopwatch. Okay, so you need to learn how to press a stopwatch, start, stop, and reset. Learn how to do that with a digital stopwatch or the manual stopwatch, depending on which version you get in your laboratory. Okay, all of you will use the same one. Okay, not basically, they are not going to give you half going to use manual. Okay, the digital one. Some is going to use the analog, not manual, sorry, the analog one. But whichever the situation is, learn how to use a stopwatch correctly. That's why, as I told you earlier, for paper 3, learn how to use the apparatus correctly. Okay, next, stop the stopwatch once the reaction is complete. Okay, as indicated in the picture, the reaction is complete when it is completely dissolved in the acid. The magnesium completely dissolved in the acid. Now, record the time taken in table 2 and repeat the steps for set 2 and set 3. Again, as I told you earlier, we are going to discuss the answer. Okay, so we are not going to have any experiment carried out. Therefore, for this part, we do not know the answer. And for your information, your answers might be different. Other schools might have it different. My answers and your answer will be totally different, depending again on the purities of the hydrochloric acid, the purities of the magnesium, and the purities of the concentrations when they were done. Okay, so all of these things play a factors, and therefore, if you realize these answers would be different from one school to another, in this particular for this particular reason, your teacher will be the one who will carry out the experiment in the preparation room to ensure that they have the same values as all of you. So your teachers also, so teachers who are joining us, make sure you master the skills also to do this experiment or any of the other experiment. Don't only ask the student to do, but you didn't master it, because what happened is that once the student got the correct answer, and if you got the wrong answers, your wrong answer will be the one as the guide for the values, okay, for the range of the values towards the student's answer. So this is the one that I told you earlier, that you're going to lose 3 marks if something is wrong here. So 3 marks is the maximum marks that I hope that we don't lose, but we hope that we can get this also. So teachers master this skill, and student, please practice the correct steps of doing the experiment so that you will be able to get the same answer as your teacher. Okay, you can get the same answer as your teacher. Okay, next one. Based on experiment 1, state 1 observation. Okay, so when you do your experiment, of course, you cannot remember because you have done 3 experiments, maybe 1, 2, and 3, set 1, set 2, set 3. So you cannot remember what is the observation. And you can remember, I did told you earlier, the picture actually give a clue. If you see, there is a gas bubbles as well as the magnesium dissolved in the hydrochloric acid. But the question is actually asking for observation. So when it comes to observation, it must be the observed items rather than what is the name. So in this case, okay, colorless gas bubble. Okay, observe. Okay, we did observe colorless gas bubble or colorless gas bubbles released. Okay, or gray solid dissolve in colorless solution. Never ever give the answer magnesium dissolved in hydrochloric acid or magnesium reacted with hydrochloric acid, because in this situation, if you do not have your eye zoom in and see the atom of magnesium, you do not know what is the identity of that gray solid that you put in. Because the question actually gave you that it is magnesium, most students make these mistakes. When it comes to observation, they tend to give the names of the materials or the apparatus used. So when it comes to observation, is what you observe. If it feels hot, then you say it feels hot. If it says the colorless gas bubble observed or liberated, then you can say colorless gas bubble liberated. But do not say, oh, hydrogen gas is liberated. That is not what you observe, because your eyes cannot zoom in into the atomic level to see the hydrogen gas particles itself. You cannot see that. But the inference is the one that we tend to do. Okay, students tend to give these answers. Okay, so when it comes to observation, it's something that you see, but it is not the item itself, the name itself. So inference, answer this. What is that colorless gas bubble? So the inference for the colorless gas bubble is hydrogen gas. So hydrogen gas release. That is to answer the first part. If you're using the second answer, in this case, the observations where the gray solid dissolve in colorless solution, then you can say magnesium, okay, magnesium react with hydrochloric solution. Simple answer, short, and do not need to go and turn it around. In the picture, colorless gas bubble observed is hydrogen. No, straight to the point. Do not give convoluted answers. Do not turn your answers around back and beat around the bushes. Never do that. Give your answer straight to the point. Okay? So this one is something you can practice. Means you can actually answer a lot of paper 3 questions to know the skills of how to write an observation correctly and how to write an inference correctly. Okay? This is a very technical questions. Okay, when I say it's a technical questions, because I have my students tend to make these mistakes. So I do hope you don't make the same mistakes as my students do. Okay, so next one, variables. Sometimes the variables can come out in this way. Basically, just straightforward manipulated variable, responding variable, fixed variable. But sometimes questions can come out. How do you manage the variables? How do you change the variables? How do you, they will give questions like that. So this is the part where I told you earlier that the questions can arrive, they are only testing your skills. In this case, the skills of writing variables. So the manipulated variables, okay, is the concentrations of hydrochloric use. Okay, this is the one from table 1. Okay, if you pay attention earlier, it is from table 1. Okay, as for the responding variable, it is from table 2. In this case, it is time taken for the reaction to complete. Some might actually ask whether or not rate of reaction can be accepted or not. For me, rate of reaction is correct. Okay, it is correct. But some students might not actually identify this as an answer. When you are doing the experiment, okay, when you're undergoing the experiment, sometimes you don't actually see about the rate of reaction, which is actually the introductions, okay, the introductions of the questions, okay. time taken or rate of reactions. Okay, whichever it is. Okay, so I'm going to give only one answer here so that we are not confused on this. Fixed variable, something that is fixed. Students tend to give this magnesium ribbon. Okay, so they will just write magnesium ribbon. That is incomplete. There must be a parameters in front of it, whether it is the size, whether it is the weight, whether it is the size as well as the length. Okay, so in this case, the one given, okay, from this question is actually the 3 centimeter magnesium ribbon. Therefore, it is the length of magnesium ribbon. Can I use the size? Possible. Okay, size of magnesium ribbon is also accepted. Okay, so variables is something that you are very you know this ever since you are in Form 1 until Form 4. So I hope that you'll be able to write variables easily. Okay, now the most important part when it comes to hypothesis. Hypothesis is always relating between the manipulated variable and the responding variable. Please write the manipulated variables before the responding variables to ease up the process of writing hypothesis correctly. Okay, so manipulated variables and responding variables. From the what you have written above, okay, from what we have done above, concentrations of hydrochloric use, okay, HCl use, and the time taken for the reaction to complete, you must make a relations between these. Of course, those that are using BM might actually be easy because they always use this semakin or jika maka type of hypothesis. Okay, but for the English, sometimes you might actually have to do your sentence a bit early, alter it a bit. Okay, but for hypothesis, never use this word different, okay, or effect. This is the kind of sentences that students tend to like to use. Okay, the concentrations of HCl use affect the time taken. They will always do that, which is actually wrong, because you need to know what is the pole, what is the polar. Basically, what is the English is the Malay is polar. Okay, what is the relations? Okay, what is the correct relations between the concentrations of HCl use and the time taken for the reaction to complete? Okay, so in this case, the higher the concentration, okay, of HCl use, the faster the time taken for the reaction to complete. Okay, what I did here is usually just use the same manipulated and the responding from the above one. Do not do this, okay? The first one, you use responding variables, time taken. But when you write the hypothesis, you actually use rate of reaction. Okay, some students tend to do this. They say the higher the concentration of HCl use, the higher the rate of reaction. But the responding variable here you use is the time taken. So please use the same thing. If you're using rate of reaction in the responding variable, then for the hypothesis, use the rate of reactions also. But if you're using the time taken above, then use the same thing below. Do not change this, or else it will actually, I'm not sure how the marking scheme is going to be, but it will actually cause trouble, not to the marker, but also to yourself. So might as well do something that is correct, 100% correct, and easy to score, rather than just try your luck in SPM. Okay, so students, do not make these mistakes, yeah? Okay, next one. Based on the experiment, compare the rate of reactions between experiment 2 and set 2 and set 3. Explain your answer. Okay, so as we know, the faster the time taken means the higher the rate of reaction. Therefore, since set 2 have higher concentrations of HCl, that means the rate of reaction of set 2 should be higher. So if you if you see this questions doesn't actually have you calculating the rate of reaction. They don't ask you to do that even. Okay, if they're going to ask you to calculate the rate of reaction, they'll give you the formula even. So that's what I believe for paper 3. Okay, this is what I believe for paper 3. If they're going to ask you to calculate the rate of reaction, they will even give you the formula. Okay, that is how simple paper 3 is going to be. Okay, so compare the rate of reaction between set 2 and set 3. So set 2 have higher rate of reaction than set 3. Why? Don't find any answers. I know previously we tend to memorize from paper 2. You have these 5 things: the frequency of effective collision, frequency of collisions, and then of course the type concentration and things like that. So do whatever, basically write the answers that which is given basically in this paper. In this case, the only point that is given is the concentration. So you're going to just say concentration of HCl in set 2 is higher than set 1. Set 3. Simple. So the answer is going to be short and simple, and is that going to be then the frequency of collision between hydrogen ion with calcium with magnesium is going to be higher, and then the frequency of effective collision between particles is going to be higher. Don't do that, because we are not asking about the collision theory. Okay, it's going to be very simple. Now, this is the part whereby students tend to dislike, which is the operational definitions. Okay, so operational definitions actually have to do 2 things. Okay, you have to answer 2 things. The first thing is what you see, and the second thing is what you do. What you see and what you do. What you see is usually the observation. So it's simple. Just write down the observation. And then what you do, okay, always refer to the step and the procedures that you'd have carried out. So when you're writing definitions, operational definition, make sure you write these answers. Do not write the definition. If you write down the definition, you might not get any points here. Okay, so operational definition, okay, you must always answer what you see and what you do. Okay, so this one can need a lot of practice. Okay, so let us see these questions first. Okay, so operational definitions for rate of reaction. So write down first, rate of reaction is, okay, what do you see? Okay, what do you see? When you see, what you observe above there is the colorless gas bubble release. Okay, or the gray solid dissolve in colorless solution. Okay, so what I do for this part, okay, rate of reaction is I add another thing, time taken, because that is another thing that we observe, the time taken for colorless gas bubble to completely release or finish releasing, okay, or gray solid completely dissolve in colorless solution. Means we write down, okay, we write down this one, we continue with this, what you see. Okay, then what do you do? What you do is in the procedure, which is in this case, you put in, okay, you put Mg ribbon into HCl solution. That is what we do. Okay, that is what we did. Okay, so rate of reaction is the time taken, okay, for colorless solution, okay, for gray solid to completely dissolve in colorless solution when you put magnesium ribbon into HCl solution. It might sound repetitive, it might sound a bit weird, but if you do these steps, which is in this case answering what do you see and what do you do, you will not get the answer wrong. Maybe you have to fix a bit on the sentence part and things like that to make it nicer or sound nicer. But if your grammar is wrong, will the teacher penalize or will the examiner penalize you? Most probably not. If you are able to define operationally as whatever you observe and whatever you have done for the experiment, then you are correct. Okay, they cannot mark you wrong. Only your sentence might be a bit tunggang langgang a bit lah. Okay, this is another thing. Can you write what you do first before what you see? Because some school or some students or the teachers actually teaches using what you do first before what you see. Be my guest. The most important part, do both. Must make sure it is both. So in total, all in all, for paper 3, the total marks is 15 only. Okay, of course, some might actually say, ah yeah, will the student be asked to write down procedure? Remember the skills that I told you earlier. There are no skills asking you to write planning experiment. There is no skills asking you to plan experiment. They are only carrying out the experiment. So do not be afraid of that. Teachers, do not so panicky, yeah? Don't panic, yeah? Okay, so for paper 3, we are done. Then we are going to go to paper 2 again. Okay, we're going to we're going to do paper 1 first. Okay, we're going to do paper 1 first. Okay, I'm going to go back to my slide. Okay. So for paper 1, okay, for paper 1, there's not much tips to give here. Paper 1 is a very simple paper, okay. It consists of 2 types of questions only, multiple choice and multiple combinations, okay. Multiple choice and multiple combinations. The choices can be either an ABC questions or ABCD, okay. But because there exist questions at ABC, I can tell you for sure, you are getting the question easier. Why? If you actually want to tembak the questions, you have 33% correct here, while in ABCD, you have only 25% whether the answer is correct or not, if you do not know the answer. So you have higher chances to get correct marks here. And therefore, in this case, by logical, you actually can score higher score for paper 1 here compared to the previous years. Okay? If there is any diagram and tables given, please pay attention to it because they are very important and it does give informations, and the notes given helps you to answer the questions. Okay, usually previously all the details, like for example what is the materials or the apparatus used in the experiment to undergo the experiment, is all stated in the sentence form. Right now, if there's any tables or any diagrams given, sometimes the information is given there. The question is very simple. Based on diagram 1, what happened? Something like that. Okay, very simple. Okay, so during this examination, please bring your pencils, okay, pencils and erasers, and make sure that pencil is something that you can clean up easily, because when you're using OMR paper and computer is going to be the one checking it, so you will tend to have this. If you have smudged in it, it's possible that they might identify as an answer. So yeah, be careful on that. So if you want to clean up your answer, rub it off, clean it off entirely. And if you actually want to mark your answers, okay, darken it correctly. Hitamkan sepenuhnya. Okay, you can actually bring your calculator in. Okay, for paper 3 also, okay, for paper 3 also, you can also bring your calculator. For all the papers, you can bring calculator. Okay, how about periodic tables of elements? Okay, periodic tables of elements. Most probably, paper 1 and paper 3 doesn't have your periodic tables of elements. Only, okay, only paper 2 have periodic tables of elements. Most probably, as I said, most probably, because we are not sure whether this year would be different compared to last year. Okay, this is another good thing that all the students nowadays can enjoy, which is there is no more negative questions. There is no question such as which of it is not correct, which of it is true except, okay, all of the statement is true except. This kind of question doesn't exist. The questions is all correct. Okay, what's the difference between multiple choice and multiple combinations? Multiple choice is just straight away A, B, C, D. Multiple combinations is 1 and 2, 1 and 3, 2 and 3, 2 and 4. Those kind of multiple combinations. Okay, so let us see an example of the questions given by Lembaga Peperiksaan for us to see the difference. Okay, you can see which of the following occurs during a reduction process of substance. You have to read if you see the question is not negative questions again, and then the Malay sentences will be on top first, the BM is on top, and then the English following by English, which is in italic form. Okay, so which of the following occur during reduction process? Okay, so if you are going to answer, okay, read it carefully, read one by one. Gain oxygen, donates electron, lose hydrogen, decrease in oxidation number. So a reduction process is a decrease in oxidation number. Okay, simple answer. So if you see the answer is D, just darken the D answer in the OMR form. Second question, whereby the question is going to be either in diagram or structural formula. So which of the following is the structural formula of a carboxylic acid? analyze the diagram carefully, okay, or the structure with the formulas, the structural formula clearly, okay. So this is OH, this is alcohol, okay, this is alcohol. This is COOH, this is carboxylic acid. And this is COO, then CH3, CH3. So that means this is an ester. Okay, this is a carboxylate group. So the question, which is the structural formula for carboxylic acid? It is B. So that's why when it comes to questions, you have to analyze the diagram given. Sometimes it could be an apparatus setup of which you have to analyze whether the, maybe like, for example, a setup of electrolytic cell, then you have to see the batteries, the anode, the cathode, the solution, everything. Check everything. Okay. Then this is a combinations question, multiple combination question. Which substance ionizes completely in water? Okay. So ammonia is a weak alkali. Nitric acid is a strong acid. Ethanoic acid is a weak acid. Sodium hydroxide is a strong alkali. Okay, this kind of informations, once you know, completely ionized in water means this is a strong part of which is a 2 and 4. C is a combination of 2. Therefore, it is a C. The answer is C. This is another heads up. For the multiple combination questions, is only 2 options. Means it's either 1, 2, 1, 3, 2, 2, 4, 2, 3, 4. They are not going to be 3 answers anymore. There is no combinations up till 3. There's no 1, 2, and 3, 1, 3, and 4. No, there's no 3 answers. There are only 2 currently. So that is another things that you quite easily help you, because there are sometimes it's like, okay, I think the answer is 1 and 4. There's no option 1 and 4. That means something is wrong, that your answer is wrong. So be careful on this. So multiple combination questions is a type of analysis questions whereby you have to see one by one, analyze one by one, then see the answers. So I am going to give you a bit of simple tips to help you with paper 1 or maybe a bit of paper 2. This is something to remember, okay? This is, I called it a bonus slot. It's something which is to remember easily, okay? The first thing that we are going to try to remember, okay? Oh, by the way, paper 1 finished. Paper 1 doesn't have a lot of things to learn, okay? Paper 1 finished, huh? So now we are going to go for something easy to remember. For those that are joining us, okay, right now, please take out a piece of paper or your note, okay, and this is a very simple thing to remember, okay. First thing first, of course you realize that it is very hard to remember the electron, basically the structure, the atomic development, okay, the atomic structure development, and who found what, and what is the kind of diagram and things like that, okay. So for that, I actually devised using this anagram. I'm not sure, is it anagram or something like that, okay, whereby I combine using the term Dr. BC. Dr. BC refers to the name of the scientist that actually involved in the developments of the structural atom. Okay, this is in chapter 2, form 4. So Dr. BC, what does Dr. BC means? D stand for Dalton, T stand for Thomson, R stand for Rutherford, B is Bohr, C is Chadwick. I repeat, Dr. BC, D Dalton, T Thomson, R Rutherford, B Bohr, C Chadwick. Okay, so Dalton, Thomson, Rutherford, Bohr, Chadwick. That means it is in order already. But what do they found? Dalton found something like a marble. Thomson, on the other hand, say, "Ayah, not enough lah, cannot do this lah." So Thomson says, "It must have like chocolate chip a bit." Okay, must have like chocolate chip a bit. Rutherford, "Oh, I agree. It is like chocolate chip, but not enough. I want to add a cherry in the center." Okay, so he add a cherry in the center. Bohr say, "No. Cherry only not enough. How can the electron go around randomly like that? It have to go in a very specific orbital." So that is where he suggested this way. And Chadwick said, "Yeah, I agree with you, Bohr. The same thing as you, but there's a bit of difference." So let me label something first. The first one is atom. The second one is electron. Of course, those chocolate chip is electrons. And then this is electrons. Since Rutherford said there's a cherry in the center, that means this is a proton. Okay, Bohr said, I agree with you. There is a proton inside and then there's an electron outside, but it doesn't go randomly. It must follow an orbital. Okay, it must follow an orbital, it says. And then Chadwick says, yeah, follow orbital, agree. Okay, but center cannot be proton only. They must also have neutron. So from this story, or from the way to memorize Dr. BC, okay, we can say that Dalton is the first person to found atom. Okay, he said that he found atom. Basically, he identified atom. Thomson is the first person to identify electrons, the chocolate chip thingy. Okay, Rutherford is the first person to identify proton. Okay, because he's the first person to found proton. Okay, Bohr is the first person to identify the orbitals of the electrons, while Chadwick is the first person to found neutron. Now, from these memorizations, okay, Dr. BC, okay, remember this step. Okay, now these questions. Who suggested this atomic structure? We do a bit of test, okay. Who suggested the atomic structures for this one? Okay, so you see, it looked like chocolate chip, and then got a center. Basically, got a cherry in the center. So the first one, see bulat with the chocolate chip. Oh, the third one. So Dr. So this is Rutherford. So the answer is Ernest Rutherford. Okay, so that's how I remember, and I hope I could help you remember easier. Okay, so B and C is very simple. Like you see the diagram, memang got the orbital already. However, okay, the first doctor means all is in the circle form, except one is a circle, the other one is a circle with electron, circle, electron with proton. Okay, so the answer is Ernest Rutherford. Okay, so that is the first simple idea, simple things to memorize. The second thing, I know students hate salt a lot. I know they hate salt a lot because there's a lot of things to memorize, especially when it comes to the ammonia, the cation test with ammonia and sodium hydroxide solution. Okay, in page 207 and 208 Form 4 textbook, there is the questions whereby they have the white precipitate. Then they will say that the white precipitate remain, the white precipitate dissolve, there's no white precipitate form. And there is so much thing with white precipitate with sodium hydroxide and also ammonia. Okay, so what I do, I use this simple table, okay, to memorize all the white precipitate form or does not form, or does it dissolve, or does it remain. Okay, this is the kind of simplifications table. Okay, so before that, okay, we must make sure it is sodium hydroxide first before ammonia. How do I know? Na before NH. Okay, Na before NH. So Na or H, then before NH3. So that means that if you put in the first one, the first column must be ammonia, sodium hydroxide. The second column is ammonia. Next, how about the ions arrangement? Okay, this one is something that my friends and I, which is around 12 years ago, we learned this together. We make this together, Ezrul and then Bob and then me. Unfortunately, my friend, one of it passed away already. So this is something that we learned together. Okay, so he said to remember the arrangement, ammonium, Zep, come on. He said like that. So ammonium, Zep, come on. So the first one is ammonium, ZAP, come on. Okay, so come on, something like that. So ammonium, Zep, come on. So you remember is ammonium, zinc, aluminium, lead, calcium, magnesium. That is how you arrange it. So you have this one, sodium hydroxide and ammonia. Okay, then what is the thing that we're going to write in these columns and basically spaces in these tables? The first one is cross, 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 cross. The topmost is all cross. The most bottom will be tick, 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 and tick. Then after that, tick, tick, cross, cross. Okay. Then tick, 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 cross, cross, cross. Or else it will be the same thing as bottom. Then tick, 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 cross, tick, tick. What does cross and tick means? Okay. What does cross and tick means? Cross means no precipitate. Tick means got precipitate. So when ammonium is mixed with sodium hydroxide, there is no precipitate form even in excess. With ammonia, there is no precipitate form and even in excess. With zinc, okay, if you put in a bit, there is a white precipitate, but the precipitate dissolve upon excess. As for the ammonia, it form, basically it have this what do you call this, white precipitate, then after that there it dissolve. This is only for the white precipitate. Okay, I refer to the white precipitate. Of course, the colored solution, you know, the blue, you know, is copper, the green is iron 2, the brown would be the iron 3. But for the white precipitate, there is a very much confusion on here. That's why I use this table. So if they say the white precipitate white precipitate remains means there is a precipitate and then there is a precipitate. Okay, so you have to understand this table as being crossed means no white precipitate, thick got white precipitate. Okay, I'll repeat this process a bit so that you can remember. Okay, slightly a bit so that you can remember. Then after that, we can do a bit of exercise to help you with this. Okay, so first, of course, Na before NH. Okay, Na before NH. Okay, then ammonium, Zep, come on. Ammonium, Zep, come on. Okay, then cross, 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 tick, 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 tick. Then tick, tick, cross, cross. Then tick, 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 cross, cross, cross. Tick, 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 cross, tick, tick. That's what it means. Okay, so this is a very nice picture of it. Okay, next one. Now, let us try and test our knowledge on this. Salt W solution is colorless. Okay, so usually the salt solution will be colorless and therefore it will form a white precipitate. With sodium hydroxide solution, white precipitate dissolve in excess. Okay, with sodium hydroxide, white precipitate dissolve in excess. Means it's a thick and cross. As for the ammonia solution, the white precipitate also dissolve in excess. White precipitate dissolve in excess, thick cross. Okay, so if you want to remember back, you usually do this. Okay, pangkas semua, tick all, tick tick, cross cross, tick tick tick, cross tick, cross cross cross, tick cross cross, tick tick tick, cross tick tick. Okay, so ammonium, Zep, come on. So tick cross, it is zinc. So this is supposed to be a zinc ion. Okay. When solution is added with hydrochloric acid and barium chloride. Barium is an indicator for sulfate. So the name of the salt, okay, the name of the salt is zinc sulfate. Okay. Formula is not accepted because the question is asked for name. Okay, next questions. Okay. Salt X solution is colorless. Okay, it is colorless. Again, the same questions. Okay, quite similar. Sodium hydroxide solution, white precipitate remain in excess. White precipitate remain as thick cross. As for ammonia solution, remain in excess. Sorry. Remain means thick and thick. As for ammonia solution, there is no precipitate presence. Cross, cross. There is only one thing, calcium. When solution is added with nitric acid, silver nitrate. Silver is chloride. So this is CaCl2. Okay, this is CaCl2. Of course, there is a possibility that this question is something other mistakes. When I say there's a mistake, because calcium chloride, okay, calcium chloride slightly soluble in water, so it's still acceptable lah in this case. Okay. Theoretically, it is still possible to get a calcium chloride. Okay, CaCl2 or calcium chloride. Okay, the next one is going to be a bit tricky. The next one is going to be slightly tricky. Salt white solution is colorless. With sodium hydroxide solution, white precipitate dissolve in excess. Okay, white precipitate dissolve in excess is thick cross. Okay, as for ammonia solution, white precipitate remain in excess. Thick, thick. If you're going to do the same method back again, or you're going to refer back to your table just then, thick cross, thick, thick, got two answers. It is either Zep, aluminium 3 plus or Pb2 plus. Both have the same thing. Okay. When solution is added with nitric acid and silver nitrate, okay, silver, again, we're going to say the silver will be the chloride ion, okay, white precipitate is formed. Identify the chemical formula of salt white. This is the things where the students have to be slightly better. When I say slightly better, because you have another knowledge you have to have, which is the solubility in water. Okay, it says salt white solution is colorless, indicating that this solution dissolves in water. So what is the possible answer here? It is either aluminum chloride or lead chloride. Which one is insoluble in water? This one is insoluble in water. Because this is a solution, therefore this is wrong, and the answer is aluminum chloride. Okay, so this is the answer, aluminum chloride. Therefore, it cannot be lead chloride because the salt is insoluble in water. Okay, so I am finished with something for you to remember with paper 1 and paper 3. Okay, following the next slot, it will be paper 2. And I'm going to pass this over to the MC now.
Thank you, Mr. Peter. So now we would like to invite Mr. Peter Chin to answer some questions from the fellow participants. So the first question is, what are the reliable sources to get exercises for paper 3?
Okay, as far as I know right now, there are a lot of states that actually did their modules. Okay, this is one of the reference point for me. The different states that actually make the modules is actually those are the one the teachers that collaborate just to think of the the question. So this is a good place to start with. Okay, and if you have if they actually already have the trial paper from different state, that is also another reliable source. Some books, okay, some books is okay, but again, please refer to your teachers, or if not, please refer to someone who might know better about paper 3 regarding the formula, the format. An example is the master trainer or the JU, okay, of each states or each district. Okay. Okay, the next questions, what are the measures or steps that should be taken to obtain a more accurate result in the experiment? Okay, so of course, usually if we can, we would like to repeat the experiment. Having a repetition in experiment would be able to get the answer more accurately. However, you have to remember this. Okay, you have to remember one thing is that you might not actually have time for the repetitions, or you may not have the time for enough chemicals for the repetition process. So usually what I would suggest is try to do as accurate as possible. Okay, usually your answer might not be different a lot between your colleagues, between your friends, as well as your teachers, unless you have did something wrong during, for example, in the process earlier is the dilution steps and things like that. Okay.
Thank you very much, Mr. Peter. So the following question is, if question asked suggests what is salt X, can I write the chemical formula of that salt?
Okay, for the person who asked this question, I think is Yao Chang. Okay, so yes, you can. Okay, you can write the chemical formula. When they said identify or suggest, you can actually write the chemical formula. Even during the process when you're writing the answers, okay, for paper 3, okay, you did see that I actually write down Mg ribbon rather than magnesium ribbon, because the formula for magnesium is Mg, so it is still possible to use the chemical formula to replace the name. The most important thing is you must make sure that the chemical formula is correct, which I'm going to touch in paper 2 later on.
Thank you, Mr. Peter. Let's move on to another question. Is there any planning question in paper 2?
Planning questions. For planning questions, it might not be a long questions. As far as we know, currently it's only appearing in only questions 11. And since questions 11 also have 4 different sub-questions, so usually the questions would not be that long. The planning questions would not be as in like you have to write down the material, the apparatus and things like that. Usually the questions would only ask about the procedures. And if they requires you to draw the apparatus diagram, they will tell in the questions. If not, straight away go to procedure. And usually this one I'm going to touch way later on in the after this.
Okay, thank you, Mr. Peter. Are there any more questions from the fellow participants? Okay, let's assume no. So thank you, Mr. Peter Chen, once again. We would now like to take a 5-minute break. The sharing session shall continue thereafter. In the meantime, we will present to you a meaningful video. Stay tuned. Now, we will display a QR code for the participants to mark down their attendance. Hello, everyone. Participants, please be reminded that you have to record down your attendance. And also, I would like to take this wonderful opportunity to introduce the committee members, who are in charge of this webinar today. So Cedric Chua is the flow manager, and Richie Cole is the one who designs the backdrop. Maxwell Lau is the technical director, and finally, we have Cho Chen Jung, who is the attendance admin. All right, ladies and gentlemen, I would now like to invite Mr. Peter Chin once again to resume his sharing session.
Thank you, Raf. Okay, so basically, as we have said earlier, we are going to go through paper 2 right now. Okay, the reason why this slot will be slightly longer, okay, it is due to the fact that paper 2 correspond to be the one of the highest contributors towards the marks for chemistry. Okay, so let us see the overview of the questions. Okay, paper 2 consists of 3 sections: A, B, and C. Okay, section A consists of 8 questions, okay, which is structured, and then B and C is essays, while B, there are 2 questions, you can select one, or if the student is very good, you can answer both. Okay, and for section C, it will be only 1 questions, and it is a compulsory. Okay, so this is the part where the students and the teachers are actually very afraid of planning experiment, which is section C. Okay, but rest assured that it is not going to be very hard. Okay, so the distributions of marks, okay, is 5, 5, 6, 7, 8, 9, 10, 10. And for section B and section C is 20 marks each. Okay, so the earlier questions will have lower marks and the later questions will have the higher mark. Okay, so as far as we have checked for the sample given by Lembaga Peperiksaan, okay, the questions consist of a mixture of Form 4 and Form 5 questions. Okay, with section A consists of a mixture of 5 plus 3, while section B is a mixture of 1 plus 1, while section C is from Form 5. Okay, again, this is only based on the sample given. It is possible that the real SPM could be different a bit, okay, could be a different combo or combination. So do not aim and target any questions. Okay, I know one thing for sure that sometimes people like to do is target questions. Okay, never do that, never target questions, just do a lot of exercise. Okay, and I would actually recommend to do more essays exercise, because from essays, when you do a lot of essay exercise, you actually helps to answer your structure part also. Okay, as I said earlier, it is the highest mark contributions of all the chemistry paper, which is correspond to 100 marks out of the 155 marks. Okay, 155. Why? Okay, paper 1 is 40, paper 2 is 100, and paper 3 is 15 only, so 155 in total. Okay, so what is the tips that I can give you for paper 2? Okay, I'm going to give you tips first before we're going to see the questions. Main reasons, we are going to apply whatever the tips is into the questions as a practice. Okay, then after that, in the real examination, you can continue using these steps and continue using these tips. Okay, so please make sure before anything else, master writing chemical formula. And I said not only master writing it, please master it writing it correctly and accurately. Okay, there are cases whereby students tend to do this, whereby magnesium, they just write it Mg like this. I know magnesium is consists of M and G, but it is wrong to write magnesium this way. It's supposed to be written as M with a capital M and a G, which is a small g. So learn how to write capital and small letter. Teacher, please make sure your students did this correctly, else it's going to affect their chemical equations. Okay, next, there are charges, and then there is also the subscript and the superscripts number. Please make sure you learn how to write this correctly, okay, which is actually the most basic in the chemistry world. Okay, so next is master the basic calculation steps. Okay, master the basic calculation step, especially in mole concept. For mole concept, later on I'm going to introduce 3 things. Okay, this is the 3 steps. Okay, the MRS steps. Okay, the MRS steps, because this one will make your answer when it comes to calculation to be more systematic and in a correct order. Okay, so MRA. What is MRA? We'll see later on. Read all the questions, okay? Make sure when you want to decide for section B, please read all the questions first. Else, when you decide, oh, I see the first question is easy, like question number 9, okay, but what happened? The section for the second part, third part, and for fourth part, you couldn't even answer it, and you actually wasted your time answering questions for the section for the first part in question 9. Then after that, next going to the question number 10. But if that things happen, say like for example that things happen, okay? Say for example those things happen. You already answer question 9A, then 9B. Then you see 9C is very hard and you couldn't answer it. You decided want to go to question number 10A. Keep that 9A and 9B. Do not crumple that paper. Continue on sending it also, because in case, okay, in case your your question number 10, there are mistakes or you actually read it wrongly and you got 0 marks from question number 10, question number 9 still can help you in getting the marks. So that means if you did any mistakes, do not cancel it out. Just submit it in. Unless, okay, question 9A you do twice. Okay, if you do it twice, please submit only once. Okay. Next, sometimes the simplest answer is the correct answer. This is the tips given to HOTS questions, okay, higher order thinking skill questions. Sometimes the answer is not very hard. It is not going to think outside of the box. The question is going to be very easy. Why? HOTS question tends to tackle daily life situations. So since it's a daily life situations, it must be something that is happening every day, but at the same time, it could be answered using a very simple chemical or a chemistry or science method or concepts. Okay, so that's why it's going to be easy. Okay, however, you might not score full mark for HOTS questions because the second part, maybe there will be a slightly harder questions behind it. An example of it, the explanation part, whereby it requires you to have higher understanding in chemistry before you're able to pick up the answer. You can, as I said earlier, for the paper 3, replace the name of the chemical with the chemical formula. Okay, you can remember, you can change it, no problems. Okay, but please make sure, okay, you master this part, the first part first before you are doing it. Unless, okay, because we are afraid that, for example, like you do the mistakes like magnesium ribbons, you do Mg ribbons but using the small m like this, then it is wrong. Okay, might as well you just write down magnesium in the full names, okay, magnesium in the full name, so that, okay, you actually can get a full mark rather than risking it and getting 0 marks. Okay, next one, how to draw things correctly. Okay, there are certain drawings, okay, for apparatus setup that I could actually give a tips on. For the sample given, okay, from the sample given from Lembaga Peperiksaan, the only things that you need to draw is the structural formula. Other than that, there is no questions about drawing apparatus setup. However, from previous years' questions, previous years' questions, okay, we have a lot of situations whereby the students actually make mistakes regarding drawing. So I'm going to give you a bit of tips in drawing certain things, okay, certain aspects of the apparatus setup correctly. Okay, again, this is not all, just a bit only. The first one is to draw liquid. Okay, so of course, you must have a container. Okay, for those that are with us, please take out the piece of paper so that you can actually make this note on. Okay, for liquid, okay, say for example, you have a test tube and you have liquid or a boiling tube with a liquid inside. Please do not leave it empty. Please make sure you do a dash line in it to ensure that it is signifies as a liquid. I know it might sound, teacher, must have something kah? Must have this dash line as an indicator this is a liquid. Okay, the first tip is for liquid. So any containers that you want to put in liquid in, okay, a beaker for example, okay, please make sure you dash line it. Okay, next one, if you want to draw a retort stand, usually I know some students are very meticulous and draw the whole thing in. Okay, draw the stand, okay, draw the whole thing, okay, and then the clamp here, and then your boiling tube, and then clamp again. Okay, so some students tend to draw this thing, okay, but I can assure you there's a simple way of drawing a retort stand. The most important thing when you're drawing a retort stand is the clamp only. That's it. That's it. You do not need to draw this thing. You can draw it if you want, which is actually a continuation of here. Basically, you just continue on drawing the whole thing. But if you are an art student, please do. But we are science students, okay? Science stream students tend to be very bad at drawing, and therefore just draw the clamp. It is sufficient, okay? It is sufficient. Okay, next, drawing when you're doing a heating process. So when you're doing heating process, we have to draw the Bunsen burner, okay? You do not need to draw the whole Bunsen burner, just draw arrow with the label heat, and that is to indicate that this is a Bunsen burner. Okay, however, just remember when it comes to beaker, okay, when it comes to beaker, please make sure that you have to draw the tripod stand and the if there's a wire gauze, all of these have to be drawn except for the Bunsen burner arrow heat, basically as in an indicator that basically that this is the heating process. Okay, the third one, it is to draw thermometer. Okay, so when we're drawing thermometer, okay, when you're drawing thermometer, some student meticulously go and decided to add in all the levels, all this dash line. Okay, you can stop doing that. You do not need to draw the whole thing. Okay, for beaker, for burette, okay, do not need to dash line. For thermometer, okay, measuring cylinder, do not need to draw the dash line. You just label it. The most important thing, just label it. Okay, just label it. There is no need for the additional line. You want to do it for aesthetical value, be my guest. But to go and measure it accurately using a ruler, don't do it. You're wasting your time. Because usually for apparatus setup, okay, it only given 2 marks, okay? It's only allocated around 2 marks. 1 mark for the apparatus setup, basically a functional setup, okay? A functional setup. The second one is usually for the label, okay? So when you only have 2 marks, you do not need to waste time drawing all the dash line accurately using a pembaris or whatever, okay, using a ruler, okay? Next one, the most important part is when you're using a stopper. If you're deciding to stopper the solution, or for example, this solution, you want to do a stopper on it, okay? So make sure stopper it half in, half out of the containers. When I say half in, half out of the container, make sure it is like this. Okay, please do not do this. Okay, you basically force it into it and you cannot actually remove it afterwards. Okay, so when you cannot remove the stopper, there is no point of doing this experiment. So you're going to lose mark in functional setup. Okay, so when you're going to lose mark in functional setup is something I would want to avoid. So liquid will lose mark in functional setup. Okay, for the apparatus setup, I don't think there is need to draw a lot of things. Okay, so for drawing, this is all the tips I want to give you. First is the liquid must be dashed line. Secondly, for the clamp or for the retort stand, you only need to draw the clamp. The third one, for Bunsen burner, you only need to draw arrow and heat. Fourth one, okay, for thermometers, for measuring cylinder, for burette, there is no need to draw the levels inside, just label them correctly. And the fifth one, stopper, make sure half in, half out. Okay, there are other additionals, drawing tips, but this one you have to refer to your teachers in case you are looking at the diagram and apparatus setup. But your reference point for the apparatus setup and for the diagram is always the textbook. Always refer to textbook instead of reference book, because we are afraid that sometimes reference book might have slight difference or some slight error which you tend to follow. Okay, so follow the textbook because the whole Malaysia is using the same textbook. Okay, so now we're going to essays. Okay, for paper 2 essays. For essays, we must underline the questions requirement. Okay, when I say must, because one of the things that I realize is sometimes students answer a lot of questions, but they don't even answer what is the requirements of the questions. And this is one thing for you to focus on. Please underline it so that you could focus on what to answer. Then identify the marks in each questions so that you could match it correctly with the answer. For example, 2 marks, okay? 2 marks. So that means when you see what is the question requirement, then you only answer 2 lines or 2 sentences rather than answering 1 paragraph, only getting 2 marks. Okay, so answer using point form, short and direct to the point. Do not need to go and beat around the bushes, as I said earlier. Do not need to go and intro what is the story about, or basically in the basically essay form, in the karangan punya form. Okay, I know sometimes students tend to do it in paragraph form, but please do not do that. Okay, please do not do that. Please answer using point form, using dot and point, ballpoint and things like that. No problem. Okay, next, refer to diagram and table very always. Okay, always refer to diagram and table because they very much helps, okay, in answering the questions. Okay, they do helps a lot. Okay, and then remember this, please answer question requirements only. This is especially true when it comes to when they ask for suggest, then you can give both the names and the formula. But sometimes the student is asking for chemical formula. So make sure you answer chemical formula only, not the name. So that's why I said answer the questions requirements only. Do not give more than that. Okay? Special tips, okay? This is another special tips, okay? Write nicely and neatly, arrange your answer in the correct order, okay? Avoid using pencil, okay? And always include the front part of the questions or the question number. Why are all of these 4 tips is very important? Okay, because, okay, this is a bit of a secret, okay? Maybe it's not the secret anymore. All your exam paper will be scanned and delivered to the examiner via a digital format. So in this case, please help the basically the contractor who do the scanning or the person who is doing the scanning to ensure that they can deliver it to the examiner easily, and so that the examiner can give you the marks that you deserve easily. Okay, if you don't arrange it correctly, for example 9A, then 10A, then 10B, then 9C, you are actually making the examiner confused when they are doing the marking process, and that actually can cause the examiner might accidentally lose marks, giving you the marks that you deserve. So the examiner actually want to give you the marks, so help them by doing these 4 tips. Arrange it nice, write it nicely and neatly. Okay, doctors to be, improve your writing first. Okay, and then avoid using pencil, as usually this is not clear. But if you have draft, okay, if you have the apparatus set up, okay, that you need to draw, you can use pencils. Okay, you can use pencils, but the labeling, please try to use pen, because this one will actually helps a lot, especially when they scan, because we're not sure how the scanning process works. Okay, next one. Okay, now is to apply what we have learned. Okay, what we have said earlier. Okay, so the first one I said is underline and pay attention to the marks. Okay, so so this is an example, which is section B. Okay, question 9. Diagram 9.1 shows that H air gas, okay, H air gas, I underline, flow into 2 beaker containing propanol and water respectively to study the property of acid. Whenever it comes to the questions of acid, you remember it always related to hydrogen ion, H plus. Okay, so write down hydrogen ion, H plus. Okay, it will actually give you an indicator, a heads up. Okay, based on diagram 9.1, compare the observation in beaker P and beaker Q and explain your answers. Okay, so when they say compare the observation, it's only 1 mark. How many explanation do we need to do? Look at the marks. 5 marks, therefore there are 4 in total explanation. Okay, there are 4 explanation in total. Okay, so when there are 4 explanation, we have to find the explanation, or you need to find the explanation, or you need to memorize the explanation. But as I told you earlier, if you have a diagram, check it out. Check it out, okay? Because it will help you a lot. Let us see this. Okay. HA in propanol, HA in water, beaker P, beaker Q. What is the observation? Oh, there is a colorless gas. There is no colorless gas. Okay. No gas bubble. So that means got gas bubble lo. Simple lo. Okay. Sorry. This is not. Sorry. This is got gas bubble. This one got no gas bubble. Okay. Next one. What is in the picture again? H plus, A minus, HA, HA. Oh, this one got H plus. This one have no H plus. As I told you earlier, we have to study the property of acid. Therefore, we have to see whether they got H plus or not. Next one. Okay. Oh, that means when they become this one, it ionize. Okay. HA ionize to H plus and A minus. while this one, HA, remain as molecule. Okay. Remember this, another tips. Once you actually have observation, try to write the inference. Okay, the observation is the gas bubble. What is that gas bubble? Okay, calcium carbonate and HA reacted with one another will form carbon dioxide gas. Therefore, again, CO2. No CO2. Why is there a CO2 gas? Because HA react, okay, react with CaCO3. While this one, HA, does not react. So if you see, there are 4 explanations. 1, 2, 3, 4, 5. Total 5 marks. Okay. So when they have a questions of comparison, I will give a tips of using a table. Use a table because it organizes your answer more neatly and you will know how many points to write. Okay. For example, this is the answer given just then. Pick a P, no gas bubble, got gas bubble. Got CO2, no CO2. No reaction between H and CaCO3, got reaction. No presence of H plus, got presence of H plus. HA remain as molecule, HA ionized in H plus and A minus in water. So, very simple answer. And remember this, when it says comparison, both must be bigger, must be given. Must give bigger P, must give bigger Q. Okay? Giving only half of it will not give you the marks. You only get the marks for each pair correctly. So that's why I said, refer to the diagram. It will help you a lot. And actually from the diagram, it actually gives you 3 marks. Okay. So remember this, once you see observation, you can give inference. This is a few things you can learn when you're doing a lot of essays. Okay. Next one. Okay. Question B. Diagram 9.2 shows the pH value of the acid. Okay, pH value of acid. HA and HB, both are monoprotic acid. Okay, both are monoprotic acid. Suggest the name, okay, of HA acid, okay, and HB acid. Predict the value of X. Okay, so underline first. Suggest the name of HA acid, HB acid. So 1 mark, 2 mark. Predict the value of X. 1 mark. Explain the difference. How many marks for differences? For explanation? 5 minus 3, 2 marks. 1, 1, 1, 2. Isn't that look very similar to a structure questions whereby a very short answer question? Yes. Actually, when it comes to essays, they are literally like a structure, only all mesh up into one. Okay. So next time, please put in your mindset that essays is not actually very hard, because I know a lot of students enjoy doing structure, but they don't like essay. So please put in your mind that essays is actually just like structure, only they are separated into A, B, C, D, basically 4 different sub-questions, or less than that or more than that. However, each of the sub-questions can be split up into smaller sub-questions. Okay, so this part you can see, oh, very simple, ma. It's only asking for a few questions, ma. Okay, so like that. So suggest the name of HA acid, HB acid, predict the value of X in beaker, R beaker, okay? And then suggest, explain the difference. Let us see the diagram. Anytime there's a diagram, look at the diagram and refer to it. Okay, what's the difference between the diagram? Oh, this one is still remain in molecules. Okay, some is in molecules. This is, so that means this one ionized partially. This one is ionized. This one all is all separated, so that means ionized completely. Okay, so that indicates that this one is a weak acid, while this one is a strong acid. Okay, how about the concentration of H plus? Definitely you can see that H plus here have more H plus, which is 5, which one is only got 2. So that means more H plus here, less H plus, means less concentrated of H plus. Okay, next, what information shall we try to see? Okay, so this is a weak acid, it is 4.0. So a strong acid will indicate that it has a lower pH than that, which is actually any values that you can put in below 4. So since it's a strong acid, I will want to give it as 1.0. Okay, 1.0. 1 is still also accepted. Okay, decimal places is not important here. Decimal places is not important here. So let's see if we can answer all of it. Oh, we still haven't got the name. Okay, so what is the name of a weak acid? Ethanoic acid. Okay, what is the name of a strong acid? Hydrochloric acid. Okay, hydrochloric acid or nitric acid or sulfuric acid. But remember this, the question is monoprotic acid. So sulfuric acid is considered wrong because it is a monoprotic acid. So the answers, name of acid HA. Okay, this is what it means by writing the front part of the question. Name of acid so that you know to write down the name. Okay, so the name of the acid is hydrochloric acid or nitric acid. Formula is not accepted. Now, name of acid HB is ethanoic acid. Value is 1.0. Okay, remember I told you earlier, below 4.0 is accepted. Means 3.0, 2.0, 2.5, 3.25. Okay, any of those value is accepted. Okay, this is an example of it. So HA is a strong acid, HB is a weak acid. Okay, then HA ionized completely in water, HB ionized partially in water. Concentration of H plus ion in water is higher than H in HA than HB. So of course, students, you do not know which one is the explanation or the points, but any of the information that you have, you can write it down. Okay, you said there are 2 explanations, but currently I have 3 answers. One is strong acid, weak acid, one is ionization, the other one is the concentration. Which one should I write? Write all of it, because all of it is still correct. It is a correct explanation. It's only as a students, we do not know which one is in the marking scheme. So therefore, write down all of it. So for question B2, 50 centimeter cubic of acid HB in beaker S is added with 20 centimeter cubic of water. Means you add more water into the beaker. State name of the process and explain the change in the pH value. So because they don't actually tell you what is the change in the pH value, okay, state the name, 1 mark. Change in the pH value, 1 mark. Explanation, 1 mark. So this is the change. What is the change? And the other one is what is the explanation? Okay, so this is the name, the explanation, and then the change. Okay, so 3 marks, 1, 1, 1. Okay, ngam ngam ho, enough. So what is the name of the process? The answer is dilution. Because when you add more water, you diluted it, so it's a dilution process. So what about the pH value? What will happen to the pH value when you add more water to it? Because the concentration is going to decrease, so that means the pH value is going to increase. So you can say an increment, okay, it increased in the pH value. Okay, and then why it happened? It's because the higher the concentration, okay, the higher the concentration or the lower the concentration, the higher the pH value. Okay, the lower the concentration of H plus ion, the higher the pH value. Okay, so higher than 4.0 or increase. Okay, changes in pH value, it increases. Okay, so that's what it means. Okay, next one. Last part, okay, in section B. Diagram 9.3 shows an apparatus setup for an experiment to prepare the insoluble salt tea. So this is the insoluble salt tea. Okay, see, the diagram do give informations. What do you have in the information? 25 centimeter cubic of 0.5 mole per decimeter cubic copper 2 chloride solution. 25 centimeter cubic of 0.5 mole per decimeter cubic sodium carbonate solution. So sodium carbonate, copper chloride. Okay, based on the information in 9.3, state the name of the reaction for the preparations of insoluble salt. Okay, so 1 mark. Write the chemical equation. Not sure, 1 atau 2 marks. Okay, 1 or 2 marks. So usually if there's a balancing, Okay, if there's a balance, then it's 2 marks. If not, it's only 1 mark. Okay, but usually I'll just write in 2 first. Okay, then calculate the mass of the salt tea form. Calculations, I'm not sure how many marks. I will usually put in 3 for the first part. Suggest one substance. One substance, 1 mark. Okay, can replace copper 2 chloride solution in producing salt tea. 1, 2, 3, 4, 5, 7. In total, it is 7 marks. So it coincides to my expectation. If not, then you have to change your mark calculation. So basically, the explain the answers when it comes to these mark allocations. It does help a lot in planning your answers. Okay, so what is the name of the reaction to prepare insoluble salt? So insoluble salt can only be prepared in one method, okay, which is the double decomposition reaction. Some students actually like to write precipitation method. However, precipitation is not the name of the reaction. The name of the reaction is double decomposition. Okay, so this is double decomposition. Next, the chemical equation. Okay, so let us see. Copper chloride, CuCl2 plus sodium carbonate and Na2CO3, you will form copper carbonate and sodium chloride. 2 need to be balanced, so that means it's indicate is 2 marks. Okay, so calculation, I did told you there is an MRA. What is MRA? We're going to see the calculation step after this, and then suggest one substance that can replace copper 2 chloride. So you want to prepare and make copper carbonate. It must be a soluble copper salt beside copper 2 chloride. So it is a copper 2 nitrate and copper 2 sulfate solution. So copper 2 chloride is copper 2 nitrate, copper 2 sulfate, then double decomposition. This is the equation. Okay. For calculations, okay, I already write it down so that it's easier for us to see. For calculation, I did say it must use M, R, and A. What does M stand for? M is mole, R for ratio, A for answers. Whenever it comes to any calculation, usually always refer to MRA. Mole, ratio, then answer. And then after, of course, you must have unit. Okay. So the mole, if you discover the mole, it can calculate via either the mole of the copper chloride or the sodium carbonate, which is 0.5 times 25 over 1000, which is 0.0125. Ratio is from the equation is 1 reacted with 1 to form 2 and 1 mole. Okay, so basically you write it down everything, or you write down the one that we want, which is in this case salt tea, copper carbonate. Okay, so if 1, 1, 1, 1, okay, that means this is 0.0125, therefore 0.0125. You can make it in sentence form, or you can make it in a table form, okay, or you can make it in any of the indicator. The most important thing is to indicate that there is a ratio written down somewhere. Okay, there is a ratio written down somewhere. Sometimes students tend to write it in a table, okay, whereby they write, okay, so here is copper carbonate, copper chloride, this is copper carbonate. Okay, I'm so sorry. So this is copper, okay, copper carbonate, okay. Ratio is 1 to 1, then this is 0.0125, this is 0.0125, okay. You can still write it down, but of course you add here more ratio. Just add this thing to indicate that it is the same as the sentence. Okay. I only have 2 columns. You can actually have 3 columns, 4 columns, depending on what you want to write down. Okay. So you can use the table. You can actually write down in sentence form. Okay. Most important thing, write down more ratio. And then, or, okay, sometimes student actually indicated in the equation itself. Okay. So whichever it is, please make sure write down ratio. Students tend to lose mark in the ratio part. Okay, because they straight away jump into the answer part. Okay, whereby they straight away times 0.0125 times 124, which is in this case 1.55 gram. The unit is gram. So it must have unit. So for calculation step, mole, ratio, answer. So if the question is already given mole, then you only answer, okay, ratio and then answer. Straight away go to ratio. Don't go straight away to answer, because some students tend to do that. Okay, next one. We're going to enter section C. Okay, for section C, okay, question in section C is going to be similar to section B. However, they are I think maybe 2 questions, okay, they are going to be different slightly. Okay, this is the things that sometimes students might actually find it a bit harder. Okay. Okay, some students actually indicate so that I can change the colors of my pen. Okay, let me see if it's clearer using this. Okay. Okay. So for diagram 11.1, okay, show the flow chart for the formations of pineapple flavoring using alcohol X and substance Z. Okay, write the general formula for the alcohol. General formula for alcohol, 1 mark. Identify alcohol X, Y, Z. Okay, so that means 1 mark, 1 mark, 1 mark. In total, 4 marks. Okay, so that means there is no need for you to identify marks where else. So right now, there is already given 1 marks, 1 marks, 1 marks, and 1 marks. Okay, so let us see the table first or the diagram first. Okay, the flow chart first. Okay, for the flow chart, you can see that it is actually alcohol Y and alcohol X, and then substance Z, and then this is the flavoring. Okay, so now you have to write down general formula of alcohol, which is actually very easy. A general formula of alcohol is CnH2n plus 1 OH. This is the general formula. Okay, this is general formula. Okay, now you have to identify what is the alcohol. So you have to go and see the pineapple flavoring, okay, and separate it into the carboxylic acid and the alcohol. Okay, so for me, I tend to do this. When I see the COO, I go to separate it like this. This part is the carboxylic acid, and this part is the alcohol. So for alcohol, okay, for the alcohol, it will be 2 carbons only. So that means this could be ethanol or C2H5OH. Carboxylic acid, okay, so substance Z is C3H7CO, okay, so this is C3H7COOH, which is 1, 2, 3, 4, which is a butanoic acid. So butanoic acid must come from a butanol. Okay, I'm so sorry. So this is a butanol or butan-1-ol. The accurate answer is butan-1-ol. So what is about the formula? Carbon is 4H9OH. So you can write down the chemical formula or the name because currently it told you to identify. Okay, so when it asks you to identify, it means right now it could be the chemical formula, it could be the name. Okay, so butanoic acid, and this is the general formula. So simple. Okay, simple. Next one. That one is like section B. If you see that, if you actually notice that it is actually literally like section B, which is actually very simple question. Now, this is the part where it's only especially for section C, okay, which is in the indicator that this is supposed to be like planning of experiment. I know some students find this is like very scary and things like that. Okay, so using alcohol X and alcohol Y. Alcohol X, alcohol Y, okay? So alcohol X, alcohol Y. Identify in A1, okay? I use ethanol. I use here butanol. Okay? Describe briefly how, okay? Describe briefly how you can prepare the pineapple flavoring. How to prepare pineapple flavoring. In your description, include the chemical equation. Okay? So for chemical equations, okay, it's either 2 marks or 1 marks, but I already know the answer is supposed to be 1 mark. Okay, so how many marks do I have to describe, or basically how to put in the calculations or things like that? Okay, we see 8 marks here. If chemical equation only take 1 marks, that means there are 7 marks for the description, which is a long description if you consider that. But you have to see that this is actually a flow chart of alcohol Y, alcohol X, which consists of two process. Okay, one is oxidation, the other one is esterification process. So when you have two process, that means the mux is currently being separated 4-3 or 3-4 lah. Okay. So that means the mux is supposed to be 7. Usually for me, I'll just separate it into 3 and 3. Okay. So oxidation process and esterification process. So as oxidation process is around 3 marks or 4 marks. Okay. So better makes more, which is in this case 4 marks. This is 4 marks. Okay. So if you see this, oxidation process is only 4 marks. Do I have to write down the procedure, the apparatus setup, the variables, the hypothesis, the aim, the tabulations of data, all those things? No, because question is only asking for describe briefly. Therefore, if you can, just describe the procedure. Okay. So I am going to give the answer straight away, okay? Because I know everyone could not remember that unless you have done the experiment or you have done the exercise for this. And usually, teachers also cannot remember the whole thing entirely. So your reference point is textbook. Go to textbook. So this is an examples of answers from oxidation process. If you are looking at your textbook, Form 5, it is at page 92. Okay, and if you remember, the process is if you actually see the steps in the textbook, it is way longer, and of course it has volume. Okay, this one is only like pour potassium dichromate 6 solution and add concentrated sulfuric acid into boiling tube. Simple. Add butanol into the boiling tube, heat the mixture gently, collect the product from oxidation using another boiling tube using distillation. So of course it will be better for you to copy down from textbook, but to remember the whole thing, it's actually very hard. So my tips, okay, this is a tips for procedures wise. You use a verb, you use a chemical, okay, and then you use a container. So when you have your sentence arranged in that way, verb, chemical, and container, for example, pour potassium dichromate 6 solution into a boiling tube. The next verb is add concentrated sulfuric acid into the boiling tube. Then add butanol into the boiling tube. See, you have the verb, chemical, container. Verb, chemical, container. So it's easier for you to make your sentence short and straight to the point. And then heat the mixture gently using a small flame. Okay. If don't have container, the other part can be another things. Okay. Heat the mixture gently in the boiling tube. You can. Okay. Collect the product from oxidation in another boiling tube using distillation method. Okay. So, of course, if you actually see from the textbook, it's a different way of being written down. In the textbook, it's going to say, measure and pour 5 centimeter cubic of potassium dichromate 6 solution. Add 10 drops of concentrated sulfuric acid. They will indicate a volume and numbers there. Okay. If, for example, as a student, you can remember the whole thing, please write it down. But I, as a teacher, also couldn't remember the whole numbers, how many volume to put in. So what I do is I tend to give these short answers. So if you know and you can write down the volume, there is no wrong and there is no harm in doing it. Okay, just remember this. Okay, when you describe briefly, because the question actually asks you to describe briefly, just make sure you do not write down the aim, you do not write down the variables. You don't need to write down all of it, the list of materials and apparatus. Okay, you do not need to write down the whole thing. Okay, so this is oxidation procedure. Okay, as for the esterification procedure, okay, so the esterification procedure would be similar. Okay, would be very similar, and this one is actually from the textbook, page 99. Okay, if you want to refer back to your textbook, it is in page 99. Okay, so the esterification procedure, okay, shortened already, add absolute ethanol into the boiling tube containing the product from distillation, which is actually the butanoic acid just done. Then add concentrated sulfuric acid and shake the boiling tube. Okay, all these steps is available in the textbook. Of course, I don't make this up myself. I refer to the textbook when I want to write down the answer. Okay, so teachers always refer to textbook for this kind of answers. Okay, and then heat the mixture gently, and lastly, collect the product in a test tube using distillation. So if you see, I don't actually indicate how many marks given here, And how many marks given here? It's either 4, 3 or 4, 4 because I do not know the marking scheme. So if I do not know the marking scheme, I as a human being and as a logical person would actually just write down as many as I know, which is the correct step. Do not write more than you are indicated. Means if this is the esterification procedure, just write esterification. Do not need to write about other things else. Okay. So for chemical equations, you can see that it is C3H7COH plus C2H5OH. Okay. And you will form the ester plus H2O. I have a question here, which is most probably the students might actually knows. Okay. If I do not know how to write the chemical equation in the sense like C3H7COH, which is the condensed form, can I actually write that CH3CH2CH2COOH? That means like this. CH3CH2CH2COOH plus CH3CH2OH means I write down the long form. Okay. Is it still correct? Okay. For those that are in the chat box, you can actually try to answer yes or no. You can give your response. You want to type in yes, you want to type in no, it's up to you. Okay. So, do you think you can write down CH3CH2CH2COOH plus CH3CH2OH? Is it possible to get yes or no? Okay. For those that are in live, okay, you can actually type in yes or no. Okay. And for this indicator, I know for sure, okay, I know this is for sure, it is still accepted. Okay, it is still accepted because it is not wrong. Some students might find it difficult to write down, okay, to write down the answers like this form, this condensed form. This is known as a condensed form because some students might actually not know how to write this. They know how to write this. My students tend to like this thing, and then sometimes they draw the whole thing. Okay, and a lot of students answer yes. I agree with you guys, which is very good. Okay, you are very good. Okay, so that means you can do whatever method. The most important thing for the procedure, for the chemical equation, just write the correct. Okay, when I said the correct, must be correct. Do not go and jumble up and tukar the whole thing lah. Go and change the order. For example, COOH, CH3. Don't do things like that, which is another common thing. Okay. Thank you for all of your response. Okay. Thank you for all of your response. Okay. Okay. Plus water. Okay. Esterification do produce water. And if you see this equation doesn't need balancing, so it indicates 1 marks only. So any equations that is not required for balancing only 1 marks, while any equations that requires balancing have 2 marks. But as a student, you do not know which one unless you actually written it down. So my suggestion, always assume it always as 2 marks. Then after that, baru potong markah from them. Just cut down the mark. Don't assume it only 1 mark. Sorry. Next one. This is the other questions. Okay, the third questions for question 11. And this question, state the functional group. Okay, set the functional group. So it says state. So that means it can be name, it can be formula. Then the functional group. Okay, functional group of the pineapple flavoring. Okay, so it indicates you need the ester punya functional group lah. And then draw the structural formula. They already give you the formula. Okay, they already give you the formula. So you just need to redraw it. Okay, so this is 1 mark. Okay, structural formula 1 mark. Calculate the mass of pineapple flavoring produced when 0.03 moles of alcohol is used in the esterification reaction. Okay, so right now I underline it as the mole. So that means I don't need the M. I straight away go for the R and then the A. So that means the ratio and then the answer. Okay. So the ratio, okay, 1 mark. The answer 1 mark. So total 4 marks. 1, 2, 3, 4. Okay, ngam. Okay. So what is the functional group of the pineapple flavoring? Let us see the picture above again. The pineapple flavoring is an ester. So what is the functional group? It is a COO. Okay. So it is a COO with a dash line left and a dash line right. Or it is known as a carboxylate group, not carboxyl group, okay? So if you do carboxyl group, it will be actually the carboxylic acid, okay? So carboxylate group, okay? So when you draw the structural formula, please indicate all the hydrogen, please write down all the hydrogen, and please write down the bond correctly, okay? Can I write like this? CH3, CH2, CH2, COO, CH2, CH3. Okay? I won't recommend it. I would not recommend you writing this method. Why? Because it doesn't show the whole bonding between the carbon and hydrogen. I know you can say, teacher, it's only hydrogen, it will definitely bond with the carbon one. Okay, but remember this, the question is specifically asking for structural formula. So please make sure you indicate everything with the hydrogen in. Okay, this is another mistake I would like to point out. There are some students that tend to write hydrogen very quickly until it looks like a letter N. Okay, please be careful. Take your time in drawing the hydrogen. Okay, sometimes it become like a letter A lah. Okay, so betulkan, draw it nicely. And then of course the bond, okay, the hydrogen bond must be correctly placed between the C, the covalent bond must be directly C and H, connecting between the C and the H. Do not ever write down like this, okay? Or CH, then suddenly the bond is here. This is all errors that you should avoid, because all of these things, it's not that you do not know. It is just sometimes I will use this word. Sometimes you feel you want to write down things very fast until it become a mistake. Never do this. Never do this. Okay, write down slowly. Take your time. Okay, you have plenty ample amount of time, which is 2 hours and 30 minutes to answer paper 2. Okay, so as I indicate earlier, we started with R rather than M because we don't need to calculate the mole anymore. So we straight away go for R and then we go for A. Okay, R and then A. R is the ratio. 1 mole of alcohol X react to produce 1 mole of pineapple flavoring. The reason why I use alcohol X is because the question actually used alcohol X. So I don't actually use the name of the alcohol X. In this case is ethanol. It's because the question is using alcohol X. So we entirely follow the questions lah. Okay, 1 mole of alcohol X react to produce 1 mole of pineapple flavoring. Okay, so therefore, in this case, 0.03 mole of alcohol X will react to form 0.03 mole of pineapple flavoring. So they are the same ratio, which is 1 to 1. If you actually see from the equation before this, it is 1 to 1. Therefore, the mass of pineapple flavoring is 0.03 times 116 equal to 3.48 gram. Unit must be included. Students, okay, this is what happened. The students straight away jump 0.03 times 116 equal to 3.48 gram. They straight away jump. But the thing is, when you don't have this ratio or indicator that actually it is the alcohol X and the pineapple flavoring have the same ratio, we do not know that. We cannot make the final answer like this. So remember this, okay? So I'm using the MRA method to identify. So mole, ratio, and then answer. Okay, next one. Okay, this is another question that is, I'm going to say this is very specific to question section C. Okay, this is a hot questions. Of course, it's either an analysis questions or it's a synthesis questions. It's either an analysis questions or a synthesis question. Evaluating, not analysis. Okay, diagram 11.2 show the pie chart for the composition of saturated fat and unsaturated fat in oil A and oil B. Okay, oil A and oil B, they give the percentage of the unsaturated fat. Therefore, the percentage of the saturated fat can be indicated. We actually can identify what is the fat in for oil A, which is 89%, and the second one is 51%. Okay, so next one. That usually this kind of questions, okay, will have a very long descriptions before the questions. Pay attention to this description because this description can be used and should be used to answer some part of the question. It actually can help. That's why I told you the answer is actually straightforward. The HOTS question is there. It is there. It's just you need to pick it up and change it into your sentence. That's all. Okay. So saturated fat contains single covalent bonds between carbon atoms. Okay. It can increase the levels of cholesterols in bloodstream but resist the oxidations at high temperature. Unsaturated fat contains double covalent bond between carbon atoms. It is easily oxidized at high temperature to form carcinogenic substance. Puan Amina chose oil B to fry the mixed vegetable and to deep fry chicken. So she uses oil B. Does Puan Amina make the correct choice? Okay, first answer, 1 mark. Give the reason with reference to the effect on health. How many reasons to give? 4 marks, 3 reasons. Okay, but refer to the effect of fats on health. We can see the effect of fats here. Increase the level of cholesterol in bloodstream, which is the saturated fat. Okay, and then easily oxidized, which is the unsaturated fat. Okay, just remember this. Sometimes some students tend to think one oil is only saturated fat or one oil is only unsaturated fat. But the case given here, okay, the indicator here is that an oil, okay, an oil is a mixture of saturated fat and unsaturated fat. It got both compound basically. It's just the percentage or the ratio of it would be slightly different. Okay, so as we said earlier, okay, saturated fat contains single covalent bond. It can increase the level of cholesterol. That means oil A and oil B both can increase cholesterol levels also. But we have to see based on the percentage of saturated fat only. Okay, because saturated fat in both oil exists, only which one is higher. So with this case, bear in mind, I put in, okay, because saturated fat can cause increase in the level of cholesterol in bloodstream. Okay, so that means oil A have higher increase compared to oil B. So that means better for health left oil B. So she make the correct choice. Okay, Puan Amina make the correct choice. Okay, Puan Amina make the correct choice. So that means the first one, I will answer yes first. Okay, done. Got 1 mark already. Okay, next. Give the reason with reference to the effect of fats on health. Okay, as we said earlier, okay, 89%, the other one is 89%. This is for oil A, this is saturated. For oil B, it is 51%. So that means we have lower percentage of fat, therefore lower increase, okay, the increments of the level of cholesterol in bloodstream will be lower for oil B. Okay, therefore it is healthier, therefore it is better for the oil B. Okay, one reason, done. Okay, reason number 1, done. How about reason number 2? Unsaturated fat contains double bond. It easily oxidizes at high temperature. This one for oil B, it is 49% unsaturated fat, while oil A is 11% only. So that means this one is easily oxidized to become carcinogenic substance compared to compared to A. But remember this, although there is unsaturated fat, there is also a saturated fat there to counter the effect of high temperature. So that means you can use it to fry, but do not use more than once, maybe once or twice, and that's about it. Okay, so you still can. So that means oil B is still correct. Yes, masih betul. Okay, so you can give these reasons also, but then you have to do a bit of alteration to the reasons. Okay, but what is the third reason? Okay, this is where you have to indicate it somewhere else. What kind of illnesses or what kind of sickness that can arise due to eating a lot of fats? This is kebat or hot, means you can actually give any illnesses or any of the answers based on your logical term or based on your logical things, okay, thinking. So my answer would be heart disease, cardiopulmonary diseases, heart attack, obesities, or arteriosclerosis, all those kind of things, all kind of answers that could actually indicate that oil B is better. Okay, so this is a sample of the answers. Okay, a samples of the answers. Okay, one Amina make a correct choice. Okay, make a correct choice. Or yes, she make the correct choice. Lower increase in cholesterol level in blood. Okay, because content of saturated fat in B is lower than A. See how I actually manipulate the answers from the sentence given to our answers. Change it in that particular way. The risk of cardiopulmonary, arteriosclerosis, heart disease is lower because the percentage of saturated fat in B is lower. Because when you have increase in cholesterol, you have higher risk of cardiopulmonary diseases, you have higher risk of arteriosclerosis, you have higher risk of heart diseases. So that means I add another reasons here. Okay, other answers could be considered also. Okay, so next answer. Although oil B contain lower percentage of unsaturated fat compared to A, it can still be used to deep fry chicken, but it cannot be used to fry many times or else it form carcinogenic substances. These please apply in our real life. Okay, this is a bit of tips on the life hack. Okay, if you have oil at home that you use to fry fish or fry chicken, and the oil already changed form. When I say change form, the indicator, for example, the color changes, or the liquid becomes thicker, or the liquid becomes in a different form already, please remove that oil. Please get rid of the oil, because that oil currently is not suitable for human consumption. As indicated in these questions, it can form carcinogenic substance, and it is the real thing. It is a real deal. This is one of the few causes of cancer in us human being. Okay, so one of the few factors that causes it, and all of these can be prevented if you actually take care of your diet. Okay, so a bit of life hacks there. Okay, now let us see for structure. Okay, for structure questions, it is not going to be a long thing. When I say it's not going to be a long thing, and if you actually see earlier for essay questions, the marks is also 1 1 1 2 or 1 2 1 2 or something like that, or 1 2 3 1. All of this looks very similar to structure. Okay, so that's why I'm not going to touch much about structure. However, these structure questions, there are a few questions that I would like to discuss due to the fact that it does helps in okay, because this question is kind of unique, and some of the questions is able to give you the tips on how to answer, okay, because it got diagram and pictures, and also some of it also requires you to refer to textbook to find the correct scheme. Okay, so let us see questions number 1 in section A. Okay, so table 1 shows 3 substances and their chemical formulae. Okay, argon, Ar, naphthalene, C10, H8, sodium chloride, NaCl. Based on table 1, state the type of particles in naphthalene. Okay, so students, please bear in mind, type of particles is not the state of matter. Some student tends to mistakenly confuse the two. State of matter is solid, liquid, gas. Type of particles is ion, atom, molecules. So naphthalene type of particles is molecules. Okay, singular or plural? Nah, don't worry about it. Those are the English things. The chemistry no need to see about the singular or the plural things. Okay, so what is the physical state? Okay, so physical state is the state of matter, either solid, liquid, or gas. So what is the physical state of sodium chloride at room condition? Okay, sodium chloride is actually your table salt. Okay, so when table salt, what is it? The physical state? Simple. It is actually solid. Okay, solid. Okay. Teacher, can I say white solid? Well, white solid is not wrong. So when they ask for physical state, don't need to add colors lah. Suddenly you go and change blue color, then it's wrong already. Okay. Please avoid doing additional answers that could actually make your answer wrong. This kind of term is known as wrong cancel right, and you do not want that to exist in your paper. Okay. Explain why the melting points of sodium chloride is higher than naphthalene. Okay. This is a question, a trick question. When I say it is a trick question, I think you know why the melting point of sodium chloride is high. You can explain that sodium chloride have a strong electrostatic forces between ions. I know that you can say that sodium chloride need a higher heat energy to break the bond, to overcome the force. Okay, you can say that. But remember this, this question is asking for explanation why the melting point of sodium chloride is higher than naphthalene. So as that point indicate, okay, higher, so that means you must compare two things. You must tell about the sodium chloride, you must tell about the naphthalene. If you only mention half of it, you get 0 marks. You get 0 marks. That's why usually this is a very good indicator for you to see. When you see higher, okay, ER, okay, means you have to compare between the two. So if you say that sodium chloride have a strong bond, okay, strong electrostatic force between the ions, then you have to say about naphthalene. Naphthalene have a weak, okay, intermolecular force, okay, have a weak van der Waals force, okay, between the molecules. Okay, you must mention the name of the bond, okay, or the and also the type of particles inside. Okay, that's the second point. Okay, more heat energy is needed to overcome the strong force. Yeah, to overcome the strong force. Okay, so I'll make a note here. If you are using the word force, then you have to use overcome. The term have to use is overcome. If you're using the word bond, you have to use the word break. Break bond, overcome force. So if you're saying electrostatic force between the ionic bond, you're using the word ionic bond, strong ionic bond, and you want to use break the bond, then it's correct. But if you're using electrostatic force, then you have to use overcome. Okay. So naphthalene, how about, then you have to mention weak. Okay. So when you mention the weak, then you have to mention the less heat energy is needed. So must do the comparison, must do both sides. Okay. Giving only half would not give you the marks. Okay. State one use of argon in daily life. If you refer to the textbook, there are 2 use of argon. Okay. So this is the answer. So molecule, solid. Okay. More heat energy is needed to overcome the strong electrostatic force between ions in sodium chloride, while less heat energy is needed to overcome the weak intermolecular or van der Waals forces between the naphthalene molecules. So if you're using intermolecular force, there is no need to write down these molecules. But if you're using van der Waals, then you have to write down molecules, because van der Waals doesn't indicate what type of particles it have in naphthalene. Okay, so this is, just then I did said there's 2 points, right? The first point is the strong bond, weak bond, okay, or weak force or strong force. Okay, the second one is more heat, less heat. So I combine everything into one sentence. Okay, so that's why it's still 2 points. So the use of argon in your textbook is used to fill in electrical bulb or used to provide an inert atmosphere for welding at high temperature. Okay, at high temperature. So this is something that is easy to get. Okay. Next one. Question number 2, 3. Okay. Question number 2 and 3. Don't worry. I actually provide you with the answers. Okay. And the questions also you can see in the drive or in the link that will be shared at the end of the session. So for those that wanted to answer question 2, 3 and the rest, you still can answer, or you have answered it. Okay. And you would want the answer is also provided afterwards. Okay, so right now we're focusing on 1, 4 and 7, because I'm choosing one question which is the low marks, one is the intermediate marks, the other one is the high end marks. Means one is 7 marks, the other one is 5 marks, the other one is 10 marks. Okay, so let us see the questions. Diagram 4.1 shows a bottle of hand sanitizer that contains covalent compound, okay, X, as the main component in hand sanitizer. Okay, so this is a propan 1-ol. Okay, state the type of bond in covalent compound X. Okay, state the type of. This is a bonus questions, but some students tend to make mistakes. Okay, because I have seen answers like this. Okay, state the type of bond in covalent compound X. The answer is actually very simple. Covalent compound. So covalent bond. Covalent compound, then it's covalent bond. Okay, but some students, because they go and analyze the diagram, single bond, so they will just say single bond. But single bond could indicate a different type of bond. It could be a single ionic bond. It could be a single covalent bond. So single bond is incomplete. The answer is not the correct answer. So if you say the correct answer is single covalent bond, that is correct. Single covalent bond is indeed correct. Okay. However, single bond only is incomplete. So the most accurate answer is single covalent bond. Without the word single, covalent bond is the easiest answer. Okay. It's very, very simple. So sometimes the answer is provided. Sometimes you just go and complicate it yourself. Never do that. Usually the first questions or second question will be easy question. You're like, huh? Like this only terima lah. They give you the marks already. You just take it. Okay. No need to question. Okay. Explain why. Okay. This is a bit harder. Why covalent compound X is not able to conduct electricity in all states. Okay. This is one thing I realized. Sometimes we already memorized too much when it comes to electrical conductivity. We tend to mention about there's no free moving ion. Okay. There's no free moving ion and things like that. Okay. But the situation is currently we are having a covalent compound. A covalent compound doesn't have ions in the first place. So then this is entirely, you cannot use the word no free moving ion because it's a wrong term for me. Okay. So if you actually check the textbook, the answer for 2 marks is actually available in the textbook. Okay. In the textbook, it actually mentioned like this only. Molecules in covalent compound is neutral. That means it is neutral and does not carry any charge. There is no mention of free moving ion at all. Okay, so students remember this. When you are mentioning about covalent compound, don't ever mention about free moving ion. Free moving ion is only an indicator in an ionic compound in a solid state. So when they are in solid state, there is no free moving ion. And when they are in liquid state or in an aqueous phase, okay, then there is a free moving ion. Then you can use the term no free moving ion, there is free moving ion. But situation with covalent compound doesn't have this indicator. They don't even have ions in the first place. So that's why we are saying molecules in covalent compound is neutral and does not carry any charges. Okay. So this answer is not something that I actually arise myself, bagi sendiri. No, this one actually from the textbook. Okay, you can refer back to your textbook, Form 4 textbook. Teachers can actually go and check this out. Okay, maybe the Form 5 students doesn't have textbook, so yeah, this one is available in the textbook. Okay, question C. Covalent compound X is also used as a main substance in the production of acetone. Okay. Diagram 4.2 shows a woman removing nail varnish. Okay, it's removing nail varnish. Okay, though it looks like they're actually putting on nail varnish instead. Okay, so based on diagram 4.2, explain why acetone is suitable to be used to remove nail varnish. Why it can remove. Again, this is a sounds like very hot questions, very hard. Why it can be used. Okay, and then can water replace acetone? Give your reason. Okay, why it is suitable? Okay, what is acetone? Acetone is an organic solvent. Okay, it is an organic solvent. Why it can remove it? Very simple answer. The word we are looking for is only D-I-S-O-L-V-E. Dissolve. Or double S. Sorry. D-I-S-S-O-L-V-E. Dissolve. We are looking for the word dissolve. So if you're saying acetone is an organic solvent, it can dissolve nail varnish, done. Or acetone is an organic solvent, nail varnish can dissolve in acetone. Therefore, it can remove the nail varnish. Okay? So, if that is the answer for the above, can I use it for the below? Can water replace acetone? No. Why? Water cannot dissolve the nail varnish, or nail varnish cannot dissolve in water. The answer, yes. That is the simple answer. That's why sometimes questions is very simple, that the answer is actually very short and precise and straight to the point. Okay? So acetone is organic solvent, it can dissolve in nail varnish. No. Water is a polar solvent, cannot dissolve in nail varnish. Simple. The only word we are looking for is dissolve. Okay? The Malay term is larut. Okay? Because it's pelarut organic, then it boleh larut. Okay? So the Malay term is easier lah because you're using the same term. Okay? Solvent, dissolve. Okay? So simple questions, simple answers, usually whether or not you want to think that it is hard or something like that. Questions like this is very simple. Okay? Chemistry is simple one. Kacang je. Okay? So question number 7. Question number 7. So diagram 7 shows two sets of experiment to study the factors affecting the rate of reaction between hydrochloric acid and calcium carbonate. Okay, hydrochloric acid, calcium carbonate. Okay, so usually when there is diagram, okay, kata the same thing I'm going to tell again repeatedly. See and analyze the diagram. Number 1, let's see first. 100 centimeter cubic, 0.25 mole decimeter cubic HCl. Okay. 100 centimeter cubic, 0.5. 0.5. Oh, so this one is more concentrated. So make a note somewhere. More concentrated HCl. So when you write down like that, okay, less concentrated HCl. So this one actually helps you a bit lah. It will actually help you, give you a bit of tips what to do lah. Okay. After 3 minutes, okay, after 3 minutes, 120 centimeter cubic, 60 centimeter cubic of gas. Oh, gas more volume. More vol of gas. Okay, less volume of gas. Okay, write it down first. You are using chips of excess calcium carbonate chips, so calcium carbonate and HCl, so CaCO3 and also HCl. So usually you will produce CaCl2 plus H2O plus CO2. Okay, not balanced. Add another 2 and it is balanced. Okay, those are the information. Okay, state one factor affect the rate of reaction. The question actually doesn't, okay, one thing I realized, the question actually doesn't say based on diagram 7.1. They don't say that. So that means when they ask you what one factor affect the rate of reaction, it can be any factor. But of course, I know students will actually say the concentrations of hydrochloric acid. But state one factor that affect the rate of reaction, it can be any factor. It can be the catalyst, it can be the pressure, the temperature, and also the size of the size of the reactant, not particles, size of the reactant, and also the concentrations of the reactants. So it can be any of the factors. Okay, it's a general factors here. Okay, what is the reading needed to be recorded? Okay, what do you need to record? The answer is very simple. It is volume of gas. Volume of gas. Write the chemical equations. I already done it. CaCO3 plus HCl. Okay, that's 2. CaCl2 plus 2. H2O plus CO2. Okay, if you realize it's 2 marks because there is need for balancing here. Okay, there's a need for balancing. And calculate the average rate of reaction. So, paper 2 is not as good, basically it's not as simple as paper 3. Okay, in this case, they don't give you the formula to calculate the average rate of reaction. If paper 3, the question calculate the rate of reaction, they will give you the formula, but paper 2, they don't. So in this case, the average rate of reaction, you have to use your noodles, your brain, to think out what is the formula to calculate the rate of reaction, which is in this case, the volume divided by time. Okay, so the volume for set 1 is 60 divided by the time 3 minutes, which is in this case 20 centimeter cubic S minus 1. Min minus 1, minute per minute. Okay, so min minus 1. Teacher, can I use in seconds? Okay, no worry, but make sure it is 60 divided by 180. You'll get 0.333, okay, centimeter cubic S minus 1. Teacher, how many decimal places are? For chemistry, as far as I know, there is no specifications of how many decimal places given. It can be 2, 3, or 4. However, one thing I realize is that if you do not, okay, bundarkan it correctly, means you don't actually put it correctly in the correct numbers, okay. If you 0.3333, okay, 0.33 is accepted, 0.3 is accepted, 0.333 is accepted, 0.3333 is accepted, until 5 decimal places also is accepted, because that is the correct answer. Okay, chemistry are not going to judge you. A chemistry teacher would not judge you on the amount of decimal places given. That is your mathematics teacher's work. The chemistry is make sure that you know how to divide this and you know how to put in the correct numbers. Even if you don't write 0.3333 here, you just straight away 60 divided by 180. Okay, 60 divided by 180, then centimeter cubic S minus 1. You don't even do the calculation. You only write down like that. It is also accepted as the correct answer. The most important thing, because it's only 1 mark, that means it must have the unit and the unit must be correct. That's all. Okay, so see the answer: concentrations of reactants, size of reactants, temperature, can be pressure, can be presence of catalyst. It can also be the concentration of hydrochloric acid. Okay, this is accepted because in that picture, it is actually referring to the concentration of hydrochloric acid. That is the only thing that is different. However, if it says the size of calcium carbonate, there is a possibility you might be marked wrong. Okay, because in that specific, basically the specific example given, it is only concentration of HCl, but the general answers all of this. Okay, this is another things I would like to remind you of. Please do not write down size of particles. Some students actually write down size of particles. Size of particles of a compound doesn't change no matter what it is in what form, in powder form or in granule form or in chips form. All those things, the size of the particle doesn't change. If it's an ion, it will be in ion form, and that ion shape doesn't change. So please do not say the size of the particles that change. Some students make this error, okay? So it's not the size of the particle, it is the size of the reactant, referring to the specific solid. If you want to say size of solid, it is correct. Okay, but size of particles is wrong. Okay, some students actually did that, so avoid this mistake. Okay, so volume of gas, we discussed this earlier, and the answer is correct. Okay. See, this example that I gave is only 60 divided by 3, okay, centimeter cubic per minute, or 20 centimeter cubic per minute. But you can actually use the 60 over 180 centimeter cubic, minute minus 1, second minus 1, okay, or 0.33 centimeter cubic as minus 1, okay. It is possible to do both, okay. Next one. Compare the rate of reaction. Okay, now if you see, this is actually quite similar to the paper 3 questions earlier. Compare the rate of reaction in set 1 and set 2. Okay, set 1 you know is 60 cm cubic. This is 120 centimeter cubic. So that means this is definitely higher. Okay, explain your answer with reference to collision theory. Okay, now collision theory comes into the story. This is where you have to tell about the FOC, FOEC. Okay, I know some using the simple term is FOC, FOEC. The frequency of effective collision and frequency of collision. Okay, so explanations of the answers must refer to the collision theory. Okay, but you can mention about the factor. Okay, so as a student, you are trained to memorize 5 sentences. Each factor you are trained to 5 sentences. So when you are given only 3 marks, how do I want to give these 3 marks? Do I select? Do I go and choose here? Do I choose that one? I would recommend write down everything. Write down everything. If you're trained to do the 5 sentences, write down everything. Because you are not sure which is the correct answer, isn't it? Okay? As a student, unless you are trained to do so many times, because we're not sure which one is the one indicated in the marking scheme even. Okay, do all the 5 things. Okay, first, of course, compare the rate of reaction. So 2, rate of reaction 2 is higher than 3. 2 is higher than 1. Okay, then the concentration, okay, the concentrations of HCl in set 2 is higher than set 1. Okay, then more, okay, more H plus per unit volume in set 2 than set 1. Frequency of collision between H plus and calcium carbonate is higher in 2 than 1. Frequency of effective collision in between particles in 2 is higher than 1. All the 5 sentences, just write it down. Okay, so whichever what is the point, who is going to give the marks, let the examiner think about it. You as a student just write down everything. Okay, so a student wish to increase the rate of reaction in set 1 by changing HCl to H2SO4. Okay, I give a bit of tips here because you can see sulfuric acid, if you remember the punya formula, okay, is sulfuric acid is H2SO4. Okay, with the same concentration. Okay, they use the same concentration. Set 1 is 0.5, just 10 mole per decimeter cubic. So, sulfuric acid also using 0.5 mole, DM negative 3. In your opinion, does he make the correct decision? Explain your answer. One is using a monoprotic acid, the other one is a diprotic acid. So for me, he did make a correct decision. Yes. Why? Because the concentrations of H plus in sulfuric acid is twice of sulfuric acid. Whenever it ionizes in water, sulfuric acid produces twice the amount of hydrogen ion compared to hydrochloric acid. So the answer is this. Yes, because the concentration of H plus in H2SO4 is twice of HCl. Or you can actually say HCl is monoprotic, H2SO4 is diprotic acid. Okay. Then rate of reaction for set 1 is lower than set 2. Okay. We use 1 is lower than 2. If 2 is higher than 1. So the points given here, the marks given here is the number of hydrogen ion per unit volume. They don't mention the concentration because the concentration is it's indicated already. But if you write it down, is it wrong? No, it is still not wrong. Okay, it is still not wrong. Frequency of collision between H plus ion and CaCO3 is lower in set 1 than set 2. Okay, if you write down FOEC, boleh kah? Boleh pa. So if you write down the concentration is lower, and then therefore the frequency of effective collision is lower, between particles is lower, okay, also can. But the one that they are going to score you on will be on this part only. So let the examiner do the thinking. You only need to memorize the 5, okay, the 5 sentences for each one. Okay, next one. Oh, we finished apparently. Okay, we finished apparently for section for the second slot. So I'm going to pass the floor over to our MC for today. Okay, Brad.
Thank you very much, Mr. Peter. So let's move on to the Q&A session, in which we would like to invite Mr. Peter Chen to answer some questions from our fellow participants. So the first question is there a way or trick to sort of memorize the color of salt or metal oxide in a solid and aqueous solution?
Okay, very good, Brian. Okay, this is one thing that I can tell you for sure. For colors of salt, usually there are a few of those that are colored. Only a few actually. The blue coloration, okay, the blue coloration is already indicated, which is by copper 2. The green coloration, okay, you want to make note, you can write down now. Blue is copper 2. Green is called iron 2. Then of course, brown is iron 3. Those are the normal colors that is easy for you to remember. For the metal oxide, okay, for the metal oxide, there is an indicator of 3 things only that need to be colors. The first one, you have the color when it's hot and cold. Okay, so copper oxide is black and black. Okay, copper oxide is black and black. Then you have the lead oxide, which is brown and yellow. Brown and yellow. Then you have the zinc oxide, yellow and white. The rest of them is only white and white. So you don't need to memorize the colors for that one already. So check your textbook for this color. Usually for the metal oxide, it's only got 3 things that need to remember. Black, black, brown, black. Black, black, brown, yellow, yellow, white. Okay. Black, black, copper. Okay. Then you have the brown, yellow, lead. Then the copper would, the zinc would be the yellow, white. As for the color of the salt, remember for the blue, green, and brown. And then, of course, at the same time, for certain salt, for example, copper carbonate. Copper carbonate is green in color. This is the things that throw people off usually. Copper carbonate is green, not blue. So these kind of things, once you actually do the experiment, you actually see it in the lab, you will remember it. Okay. Aqueous solution usually, as I indicated earlier, when you see blue color, you know it's a copper. When you see it's a green color, you know it is a iron 2. And when you see it's a brown color solution, it will be a iron 3. The rest of them tend to be colorless or the white color. Okay.
Thank you, Mr. Peter Chin. Now we would like to move on to the second question. So how can students avoid making careless mistakes?
Okay. This is one thing I can give you tips on. For careless mistakes happen because you are sometimes very anxious and sometimes very stressed out, want to very quickly answer something. You are afraid that there's no time. Just remember, when you are answering the questions, there is ample amount of time. So underline and read carefully. So for me, to avoid careless mistake, number 1 is underline all those questions. Okay, underline it using pencils. Okay, to help you basic focus on their answers. And then after that, you'll be able to arrange your answer correctly. Okay. And another thing, please calm down. Do not be very anxious and very scared of the examination. Okay. It is just exam. Okay. It is not about life and death. Okay.
Thank you very much, Mr. Peter. So the following question is, knowing that chemistry requires a lot of understanding and memorization, what are the tips or techniques to study smart for chemistry?
Okay, Daryl. One thing for sure is understanding is the most important part for chemistry. When you understand it, you do not need to open any textbook or you do not need to open your reference book already to answer it. And that is one thing I realized. I don't need to answer whenever come to electrochemistry's questions. I do not need a textbook to open to know the answer because I understand it. Same with the concepts of when it comes to mole, when it comes to explanations, acid and base reactions, when it comes to any reaction, if you understand it, you do not need to open textbook because that is sometimes an example given for a specific acid or specific metals. But if you understand the concept, you'll be able to answer a wider range of answers. For memorization's part, there are a few tips, okay? Number 1, okay, if you have to memorize definition, this is one thing I realized, that definitions is one of the things that we have to memorize. Definition, please use a notebook or a small book, okay, whereby you write down all the definition from textbook, okay, Form 4 and Form 5, and use this as your reference points. When you read it many times, you tend to remember it. And then, of course, answer a lot of questions. This is the second tips. Answer a lot of questions. When you answer the questions already repeatedly, you'll be able to get the memorization or the definition correctly. And then, of course, for certain memorizations, especially when it comes to salt, okay, when it comes to salt, this is the things that kind of throw people off. So that's why I helped you just then with the earlier session, whereby for the test with ammonia, and also ammonia water, as well as a sodium hydroxide solution. So this is the few things we can use. You can use the table, you can use anagram to remember this. Periodic tables of elements, you can use a songs or something, you can use a sentences or a story to help you remember it. For me, to study smart, okay, once you actually master all of it and you're afraid your answer is wrong, say for example, that is where you go and check the marking scheme for your book, okay, marking scheme from the test trial papers and things like that. That is where it helps you to fix your sentence to make it a more accurate to the SPM formats answer.
Thank you very much once again, Mr. Peter. So the following question is that, how about a quest solution? Is it drawn the same way as drawing water?
Yes, Siwei Tang, it is the same. Basically, when it says aqueous, it means it contains water, and in liquid also you can use dash line. You must make sure you have dash line. So, like example, just water in a basin, okay, it still have to dash line. When it comes to liquid aqueous solution, please put in dash line.
Thank you, Mr. Peter. So what's the difference between describing an experiment and planning an experiment?
Okay. Describing an experiment means you have to describe the process only, means the procedure. Planning an experiment usually requires you to plan from the start, means including the aim, the objective, and basically all the variables, and then the hypothesis, the materials and apparatus, all the things that planning an experiment, okay, questions require planning an experiment, would be quite a harder question. When I say it's a harder question, it's a synthesis type of question. And usually, I don't think the question will come out planning an experiment of the experiment that you have done. Okay, they tend to plan an experiment or do an experiment that never existed. After this, you can go and have a look at question number 8, structure, whereby you have to plan the procedure. When I say plan the procedure, how to differentiate between a soap and a detergent, okay, using magnesium sulfate solution, okay. So that is considered like planning the procedures of something. So usually, I don't think any experiment questions in SPM will come out planning a whole complete experiment, because planning a whole complete experiment usually a very high score. I mean, it will have a very high marks, 10 marks in total, because you have to remember each procedure is 1 point. One step of the procedure is 1 mark. So if your procedure is going to be very long and you have planning of experiment, that means it's going to take out around how many percent of the marks out of 20. And usually, a question in section B or section C is divided into 4 subsections, 4 different questions. So when you have 4 different questions, you cannot have up till 20 marks in one questions and the rest is 0, which is kind of impossible. So I don't think they will have a plan and experiment questions in section C. This is my opinion, in my opinion. But there is possibility of describing an experiment a lot of time, describing the procedures. Okay.
Thank you, Mr. Peter. So the following question is, for the definition of heat of precipitation, if the question does not mention based on the experiment, do we just write in general or still based on the experiment?
Okay. For definitions of rate of reaction, see the question. Sometimes the question actually will indicate based on diagram 1. Okay, that means you have to base on the definition there. But general, for me, general definition is accepted. Specific experiment is basically lebih dialu-alukan. We kind of prefer it to have the specific experiment, specific definition if the question actually says based on diagram, means something like it asks you to define it based on the diagram. But if not, okay, that means usually you can actually give a general rate of reactions definitions. Okay.
Thank you, Mr. Speaker. So the following question is, what sentences should we use in writing procedures? Active sentences or passive sentences?
Okay, a very good question. Okay, this is another thing that throws students off and teachers off. One thing I realized is the teachers doesn't the marking scheme or the examiner actually doesn't care whether it's an active sentence or a passive sentence, because we are not English teacher. Okay, so they are good whether it's an active sentence, for example. Okay, pour the potassium dichromate 6 solution into a boiling tube. Potassium dichromate 6 solution is poured into a boiling tube. Both sentences are correct. English speaking, both are correct. Active or passive, there is no reasons to mark you wrong. So whether you want to use active sentence or passive sentence, up to you.
Thank you very much, Mr. Speaker. So the following question is, will the candidates be asked to draw the graph? If yes, is it being drawn in curve or connecting one point to another with a straight line?
Okay, drawing graph is a very tricky question. Remember when it says to draw graph, it could come out in paper 3. okay, because in communicating part, or it can come out in paper 2. So when you are asked to draw in paper 2 or paper 3, just remember this. If you see, okay, you can see the pattern and it is a curve. Indirectly, you draw a curve. And if it's a straight line, then draw a straight line. This one, it depends on question. This is a very hard thing to answer unless you see the questions and you be able to mark clearly whether or not it is actually a curved line or a straight line. Okay, so yeah, it depends on questions.
Thank you, Mr. Speaker. Let's move on to another question. Is it necessary for us to write the word ion after H positive? For example, H positive ions.
Okay, very good questions. Okay, H plus is an ion itself. So without the word ion, it's still correct. H plus ion. However, if you're saying hydrogen ion, it must be mentioned the word ion, means hydrogen ion. Okay, so if you have H plus, there's no need to mention the word ion, is still fine. But okay, this is the things that happen usually for metals. Okay, for metals, for example, potassium ion. Potassium ion is K plus. However, there are situations that students write just potassium by itself. So potassium by itself is just K. So the term H plus there is already the formula. So you do not need to write down the ions there. Okay. H plus ion is just a normalizations that we tend to do because we want to indicate it's an ion. But without the ion, it is still correct. H plus only. Okay. But for the term, like for example, hydrogen ion, you need to have the word ion there. Without the without the word ion there, hydrogen could be indicated as a gas, and this is wrong. Okay, this is entirely wrong if you're doing an explanation. For example, frequency of collision, okay, frequency of collision between hydrogen and calcium carbonate is higher in 2 than 1. So this is a wrong sentence already because it's a hydrogen ion. Without the word ion there, it's a wrong statement. So with the ion there, then it is correct. But if you just write H plus and CaCO3, it is a correct sentence.
Thank you. The next question is, can we ask for the materials to redo the experiment if we failed the experiment in paper 3?
A very good questions. I do hope you don't fail the experiment. I do hope you don't fail the experiment. Okay. But if there is a surplus of materials for you to use, you can ask for it. But I'm not that sure whether or not they actually have an extra materials inside there for you to redo the experiment. But anyway, if you have, say for example, like you fail to do the experiment, okay, say for example you do fail to do the experiment, continue on answering the whole thing first. I mean, continue answering the questions and proceed on the other experiment first while waiting for maybe the materials to arrive to you. Say for example that is the case that happened to you. But again, I do hope you don't fail the experiment. Okay. Even if you fail, okay, even say for example the worst come to worst, you fail and there is no more material, there is no more apparatus given to you, you will maximum lose around 3 marks only. 3 marks out of 155 marks is actually a big difference. So don't feel panic, don't feel so scared and panicky and things like that.
Thank you, Mr. Speaker. Now let's answer one last question. Can I answer essay questions through the point form?
Okay, the answer is yes. Simple. I already given the tips earlier. Everything answer in point form. Okay, answer in point form. Or if you want to use a table, use a table. Okay, it's very easy to arrange and also makes your answer more in a correct order, and it's actually look nicer and easier for the marker to find your points.
Thank you, Mr. Speaker. Sorry for the distraction. I would like to offer one more question. So how to write the answer for suggesting a method to handle all the variables in the experiment?
Handle the variables, or how to suggest to write handle variables. Okay, so when it says a manipulated variables, okay, how do you do a manipulated variables? You know, it's something, the variables that need to be changed. Okay, so this is something you need to change. So you said use, okay, an example, use a different concentrations of sulfuric hydrochloric acid. For example, the previous in the paper 3 example, use different concentrations of hydrochloric acid, which is a 1.8 mole per decimeter cubic, 1.4 per mole per decimeter cubic, and 1.0 mole per decimeter cubic. Okay, how do you handle the variables for the responding variables? Then you're going to say, record the time taken for, you know, those kind of things. Record the time taken for the experiment to occur. Okay, and then about the last point, how to fix the variables. Use the same. It's just basically just make the sentence in a way that, oh, we are using the same thing, you are using this one a different concentration, or this is how we get the responding variable. Okay, so there is no specific sentence for you to write. Just make sure you know how to correctly, okay, handle the variables. Okay, correctly handle the variables. That's all.
Thank you, Mr. Speaker. I believe all of those online have enjoyed your amazing presentation. Now, we would like to display two different QR codes. The first QR code is for evaluation purpose, and the second QR code is for the fellow participants to have access to the materials used throughout the webinar.